6, 5, 4, 3, 2, 1. Welcome all of you and our distinguished panelists who have joined today for the inaugural of Surface Engineering and Corrosion Control online exhibition and conference, which is taking place on the Integrated Oil, Gas and Power online exhibition. We welcome you all, and we welcome all the delegates and the partners who have been supporting and who are viewing us on the live platform. As you are aware, corrosion is a very major problem for the oil, gas and power industry. And that's the reason that we are doing the second edition of the Paint and Coating Forum. Previously, we had done in February during Chemtech. For last 2 months, we had deliberated and come across the theme on innovation through collaboration in reducing corrosion problem in oil, gas and power industry. And 2 days of interactive session has been planned with the inaugural and 3 technical sessions. I now invite our CEO, Mr. Hemant Shetty, for his welcome address to all the delegates and esteemed panelists of speakers. Hemant sir, over to you.
Good afternoon to all, and welcome to the opening ceremony of our Surface Engineering Coating and Corrosion Forum. As my colleague Sudhanshu just mentioned, it's a 3-day exposition and a 2-day conference focused on surface engineering. Our event opened yesterday morning. The first forum was focused on exploration, which was chaired by Director Exploration of ONGC and co-chaired by Director Oil India, Mr. Goswami. We had the Additional Secretary Petroleum, Mr. Amarnath, as the chief guest in the morning. After that, we had the opening of the Gas Forum, which was conducted by Director Marketing of GAIL, who was chairing that committee. Following, the opening was of Refining Committee, which was chaired by Director R&D, Dr. Ram Kumar of Indian Oil and Corporation. And after that, we had the opening of the Power Forum, which was chaired by Director Projects, Mr. Bhattacharya of NTPC. We had our good friend, Mr. Suresh Prabhu, who was the chief guest for the forum, who was the former Power Minister and presently the Member of Parliament and in the Prime Minister's office. We had same the NTPC and all. Today also, as my colleague Sudhanshu said, we have 4 additional parallel forums on all the other topics which I just mentioned, which is running parallelly, and the opening of the surface engineering and coating. It gives me great honor and pleasure to, first of all, thank you, Mr. R.P. Pandey, who is chairing this surface engineering and coating forum. He is the executive director of ONGC, who has helped us in shaping this program and actively helped in getting good support from the industry. That's how we are happy to announce that we have over 500 delegates who have already registered for the forum, and over 350 are already live, and more would be joining. And if I understand correctly from my colleague who told me in the morning that we could touch close to 700-800 delegates for surface engineering coating alone. At the same time, we have an exposition platform which is running, where we have over 2,000 visitors who are online right now, who are actively, interacting with the participants, certain delegates, and they can also view live because this is streaming live on YouTube. My welcome to my good friend, Mr. Batra, who has been associated with Chemtech for decades. From his Asian Paint days, I remember, and he has been a strong support for all our Chemtech events and helping us for our surface coating. He was very active in helping us getting the speakers and even sponsors, so that we make this event a success. My welcome to Dr. Professor Raja for accepting our invite to come and give the keynote. My welcome to our good friend, and I say our part of the Chemtech family, as if he allows me to say that, Mr. B. Narayan, who has been associated with us for decades and a very strong support. And I can always say anytime we call him, he will never say no to us. We are extremely thankful, indebted to him that he has been a great support to us and a great to all our team. We look forward to his guidance and support all the way. Thank you, sir, for taking out time and accepting us to be the guest of honor. Thank you once again. My also thanks to our good friend, Mr. Chaudhary, who is our technical head of the committee, who has been involved with us in working on the program. And also thanks to all the delegates who have registered, all the sponsors who have supported us, ladies and gentlemen. I once again welcome you all and thank you for joining us today.
Thank you, Hemant sir, for your welcome address. Now, I would like to welcome Mr. K.L. Batraji, Advisor Chukuku Marine Paints and the convener for today's program. K.L. Batraji is Advisor Chukuku Paints Private Limited since 2014. Prior to this, he was the Managing Director of the company. He was also the head of industrial business of Asian Paints Limited for 10 years with numerous portfolios which he has over the last so many decades. And also he was the convener for the paint and coating program which was held in February and which received very strong support from the delegates and the audience and the speakers. So over to you, Batraji, for your opening remarks.
Good afternoon. Thank you very much, Mr. Nagar. Good afternoon to all of you, particularly Mr. Pandey, Mr. Narayan, Mr. Shetty, and my other Dr. Raja, who has been my colleague in NACE as well as in Chemtech and IIT. I'm a visiting professor at IIT Bombay, and we have been closely interacting with Professor Raja. I go back to 1980 when the epoxy was introduced to the industry, and in Asian Paint we were very particular about 10 coat of epoxies for UV apple towers, and it was a struggle. In 1990 we introduced our epoxies in Chemtech, which was held in Nehru Center in Worli. Epoxies and polyurethane have become a standard normat, whereas in 1990 we used to struggle with change from the zinc phosphate primer to inorganic zinc silicate primer. Fortunately, this conference has come at an inflection point where polyurethane as well as epoxies have been accepted by the industry as a standard thing. But we have to move on, and today we are having systems which are go much beyond polyurethanes and epoxies, and I'm so happy that the whole industry is contributing with the new technology. So with this inflection point coming at this point of time, and the conference coming at a point of during this time when all the industry is willing to accept a new form of technology in various fields, and various technologies have come. On one side you have fluoroethylene paints which can last up to 50 years, and you have other epoxy paints of the various types. Unfortunately, coal tar epoxy has almost died because it creates a lot of problem for the environment. So thank you very much for all of you to contribute to your might with new technologies in different fields. And I'm sure there will be new norms which will be coming up rather than we still talking about epoxies and polyurethane. Thank you very much, and go back to Mr. Nagar.
Thank you, Batra sir, for helping us shape up this program and your strong support as always. Now I would like to introduce the Shri R.P. Pandeyji, Executive Director, Chief of Onshore Engineering Services, ONGC Delhi, who is the chairman for the Surface Engineering and Corrosion program. Under his leadership for last 2 months, we deliberated, we discussed with the other advisory board members to finalize the conference program, to finalize the technical sessions, getting speakers nominations, and also getting participants. and delegates. Shri R.P. Pandey is presently posted as the Executive Director, Chief of Onshore Engineering in ONGC, with over more than 37 years in pipeline management. He has been associated also with India's longest Hazira, Vijapur, Jagdishpur gas pipeline during his tenure in Gas Authority of India Limited. With numerous works portfolios behind him, I would like to welcome Shri R.P. Pandey for his chairman's address.
Thank you. Good afternoon to all. First of all, I thank Chemtech for giving the opportunity today. And I feel privileged to be associated with today's program. Distinguished guest, Mr. Sudhanshu Nagarji, Mr. Narayanji, Mr. Batraji, Mr. Hemant Sethi and Manoj Jakkarji, Sanjay Chaudhary, all those distinguished participants and delegates present here. You see, corrosion, surface engineering and corrosion, those are very close related words. So corrosion is a very, very important, it started since the iron ore was, steel was invented. Corrosion started from very, our primitive days. And its control was only the biggest challenge. Corrosion problem is a perennial issue in all industries. It may be oil, gas, petrochemical, any industry, because it leads to a deterioration of the functional property of the assets. So the global cost of corrosion, what NACE has estimated, is nearly 3.4% of the global GDP. Can you understand what is the volume of the corrosion impact on the economy of the total global economy? And by using available corrosion control practices, it is estimated the saving of between 15 to 35% of the total.
Can't hear you. Something has gone wrong.
Mute, I think.
Mr. Pandey, we can't hear you.
Often following costly business interruptions due to failure of equipment, assets to perform as intended. Cost saving from the corrosion control are often not obvious for some period of time. Maintenance cost slowly decreases, the monitoring or inspection cost decreases, or inspection interval increases. Fewer failures save lost production time and lost product, decrease injuries, decrease property damage, decrease in environmental releases, and improve public relations. Life extension of the asset, achieving the most benefit from the corrosion control practices is dependent on good business decisions. One of the most significant success story in the corrosion management is the change in corrosion management strategy and application of innovative technology in the automotive industry. So this was a global change involving all the top manufacturers since 1975. Manufacturers have created a coordinated and balanced effort between the advanced in design, material, and processing. The automotive industry has moved from one that is minimum corrosion control, where the cost of corrosion was primarily maintenance and loss of capital, and the life of an automobile was often determined by the corrosion of the body and the frame. State-of-art corrosion control through advanced painting, coating technology, and use of corrosion resistance materials, resulting in competitive advantage and warranties against corrosion. The transformation in corrosion management strategy by the automotive industry was a decision at the highest level of an organization, resulting in the lower corrosion-related manufacturing costs, lower corrosion-related operating costs, and longer life of automobiles for the buying public. The oil and gas industry is a capital industry where I am working with the asset ranging from the wells, well risers, drilling rigs, offshore platforms in the upstream segment to the pipeline, LNG terminals, refineries, midstream, downstream segments. Corrosion has been a major cost in the operation of oil and gas facility. Major challenge in the upstream industry is that assets are in remote locations, harsh conditions that make difficult to maintain. The application of paint coating is a cost-effective way of preventing corrosion. Paint coating acts as a barrier to prevent the transfer of electrochemical charge from corrosion solution to the metal underneath. The most important factor for successful of paint system are adhesion and continuity. Because of the application process, brush or spray, there will be already be some inconsistency in the coating thickness, particularly at the corners, edges, and there is no coating or protection on the interior of the hollow structure. Today, oil and gas industry need exceptional lifetime of paint in extreme condition without maintenance, high adhesive resistance, and fast curing time. Reduced material, this is what, and the realizing the maximum benefit. One thing I also want to mention that there are so many for any coating remains in the coating is the first primary protective layer of any material from corrosion. Second layer may be CP and only applicable at the location where the coating is damaged. There are so many types of coatings and new products available, and more new state-of-art products are coming out in the industry. Many of them guaranteed to be corrosion proof, and I'm sure they are, and they work 100% in the perfect system. But metals are still corroding, and we are using the asset value in terms of external metal loss over time. With the term, we do not like to think much about which is corrosion rate. Corrosion is a non-linear and can be exponential too. Measured in mm or mils per year, it is like a speedometer, which is accelerating rate at which we loses metal at certain spot due to active ongoing corrosion. There are some excellent coating available in the industry, and we keep getting better and better ones. But the issue is not so much on the coating, but type, but material, which is industry has mastered, but now more on the application part. So we have experienced that application part is really somewhere there is a lacuna in application part, which is not whatever the manufacturer is guaranteeing because of improper quality and right person for the coating application, and that is the only thing where area is required. So with the application of this surface preparation, that is, a surface roughness is not performed properly, which means there is a dirt, grease, sand, particles, water, rust layer or present in the steel before coating applications. So basically what I want to see, tell that today, the paintings technology, we have gone long way. We have achieved so many things in paintings, but surface engineering, that is surface preparation, is most important. And plus trained people for the and right people for application, surface preparation. If it is applied in as per the what OEM says or what is the specification says, if it is 100% implemented, I think the painting and corrosion can be arrested. So at last, I will say that corrosion is a very important chapter in our oil and gas industry. We have so many 262 installations in offshore, 268 installations in onshore, more than 5 plants. So we have a huge expenditure on the painting in oil and gas. Likewise in pipelines, like in Oil India, you cannot imagine what is the scope for the painting and corrosion painting in India. So I feel today's meeting, today's program will cover all the challenges like the high speed dry, perfect coating, and drying time should be less. Temperature should be applicable to all. High temperature coating should be available. So industry will discuss at least coating should be not live design should be. If the industry can achieve 10 years, and it will really be most admired and activity will be called for. Again, I thank you all for participants who have done. They will debate and discuss threat to bear of the corrosion and surface during this meeting, and it will go long way in resolving our painting issues. And with this, I thank you all of you present here for giving your duty. Thank you very much.
Thank you, Mr. Pandey, for your remarks and setting the tone for the today's event. which is highlighting obviously on the importance of surface engineering and corrosion control. We are very honored to have with us our guest of honor, Mr. B. Narayan sir, Group President, Procurement and Project of Reliance Industries. As our CEO, Mr. Hemant Shetty, has already introduced him, that he has been associated with us since decades with the Chemtech series of events in the key advisory roles and as a chairman for advisory committees, various. Mr. Narayan has over 57 years of experience in project procurements and contracting management. In the last 40 years with the Reliance Industries, he has played an important role and contributed significantly towards his phenomenal growth through implementation of various capital projects in polyester, petrochemicals and refinery sectors located in Patalganga, Hadira and Jamnagar sites, and also very, very long decades of his experience in the industry. With this, I would like to welcome our guest of honor, Mr. B. Narayan, for his address.
Thank you. First of all, Sudhanshu, a small correction. 47 years experience, not 57. If I had a 57, I would have started job as 15 years old. So it is not so. Okay, that's small correction. Secondly, thank you very much, Chemtech Foundation, for giving me this opportunity to come and speak on this occasion. And Mr. Hemant Shetty, thank you for those kind words. And Batraji, Sudhanshu, and panelists on this in this panel discussion, Mr. Pandey, Mr. Raja, and then you already have spoken, Ms. Batra, and all the delegates who are attending this conference. Now, as Mr. Pandey mentioned, corrosion is a big menace. It is it costs the world heavily, and as he mentioned, the cost of corrosion control is of the order of 3.5% to the GDP. You know, even in the countries like USA, which is developed countries, it is of the order of nearly 4.5%, and countries like us, which are developing countries, maybe it is even higher. And so it's an important subject. There is, I mean, however much you put emphasis, it is insufficient. Number one. And then, you know, wherever you go in your daily life, you see corrosion. It's a natural phenomenon in the nature. And whether you travel by bus, train, airplane, or ship, or you drive on the road, you see the advertisement hoardings, the bridges, the dams, and also the buildings that you live, or some of these places where it's only you can see the corrosion effect. So it's sometimes it's what I would say great eyesore to see the effect of corrosion. And so what is actually a corrosion? Because very specific to the project of today's discussion, I would subject to discussion today. I actually would like to just mention, and because to bring the subject to the context, you know, what is corrosion? Corrosion of metal is a chemical or electrochemical process in which the surface of metals, the surface of surface atoms in the metal react with substance that comes in contact with the surface. So that's fundamentally the corrosion process. And usually the corroding media is liquid, or also the gas or the solids can also be corrodants. And then the electrochemical corrosion in metals in natural environments such as air, water, or even underground soil, it's caused by flow of electricity from one metal to another metal, or from one part of the metal surface to another part of the metal surface, as long as there is a condition for permitting electricity flow. You know, so these are the two elements of the corrosion, which is very relevant for today's subject. And in the corrosion process, there are two reactions taking place: the oxidation and the reduction. The rate of oxidation and rate of reduction are equal. And so what you have an anode, you have a cathode, and in the anode, you have oxidation taking place, you are in the cathode, reduction taking place, and in a process, there is a continuity established, and the current flows through the electrolyte, which is either moisture, water, whatever medium. So you have now in the cathode end, there is a reduction reaction taking place, resulting in generally production of hydrogen. A very thin layer of hydrogen is formed on the cathode surface, which actually prevents the continuity of flow of the electricity now. Actually, the corrosion will stop at that. But unfortunately, it is not going to be so, because if there is oxygen present, then that oxygen reacts with hydrogen, that thin film is broken, the electricity, the continuity is re-established, corrosion continues, oxidation process continues, reduction process continues. Point of the matter I'm actually trying to stress is, so all of these are happening at the surface of the metal. So it's important, if you want to now control that corrosion and eliminate or mitigate or reduce, you need to treat and handle that surface. And that is exactly what is meant by either a surface treatment or surface engineering. Now, I would be not doing my duty if I did not cover the erosion part along with corrosion, because surface engineering also involves tackling the erosion problem. And exactly the same way, the metal surface engineering involves mitigation or addressal of the erosion. So how do you do? So there are many ways of modifying the surface of a metal which is generally subject to corrosion and avoid and in order to avoid corrosion, if you have to modify, how do you do? For example, if I were to take gears or a compressor blade or a turbine blade, all these are, if you have a very high speed pump and where the tip speed of the impeller is so large, so these are the very susceptible parts of an equipment where it comes in contact with abrasive or erosive material. So there will be erosion problem. And it is more enhanced, more pronounced if that particle which is coming in contact is corrosive as well as erosive. So what do you do for erosion? Tackling erosion, you have to harden the surface. Take the example, as I mentioned, either harden the surface or do a coating depending on the temperature of operation, as long as the coating stands. So how do you do the hardening of the surface? There are many methods. These are all as part of the surface engineering. You do flame hardening or diffusion heat treatment like carburization or nitriding, or a laser or electron beam hardening by spraying, applying very high energy. And also there's a process called short peening to improve the fatigue properties. You stress this element, and so you improve the fatigue properties. So these are some of the ways in which you can tackle the erosion problem. Coming to the corrosion part of it, steel is a common metal that we use for simple reason that it has got strength, it has got ductability, it has got ease of fabrication, it has got dent resistance, and it's got every possible properties that you're looking for. At the same time, it is inexpensive. And unfortunately, it is susceptible to heavy corrosion. So how do we do that? So again, we come to the topic of surface engineering of metals to avoid corrosion. And you have several processes Because as I mentioned earlier in the opening remark, you need to treat the surface, you need to engineer the surface. So there are many, many methods of engineering the surface. And for example, alloying the metal itself. Say, take for example, steel itself. So alloying with chromium, nickel, and superior material. By doing that, the corrosion properties of metal will be much improved, means it will be reduced. You have hot dip galvanizing, which is a very normal, the process that everybody is used to. You see the galvanized sheets, galvanized steel, etc. And then you have the aluminizing. And you have also anodizing. The titanium, people think the titanium doesn't corrode. It does corrode if it is subject to very high acidic, like acetic acid medium, titanium corrodes. So you need to do anodizing to treat or engineer that surface. Electroplating, like you have chrome plating or nickel plating, thermal spraying, then vapor deposition technique for very hard coating. And unfortunately, with the higher temperature and higher pressure, the problem becomes more severe. So you need to tackle the process with probably higher expensive process. You'll have to adopt. So depending on the cost means, when I say it's a life cycle cost, so initial cost plus operating cost for maintenance, and you take into account also the size restrictions. For galvanizing, for example, the galvanizing tank size limits the size of the material that you can galvanize. So you also have other constraints, like the technical properties itself. So you require, for example, the distortion tendency of the material. So you cannot, if you have to deal with that, so you need to apply a certain process that you're then taking care of that as well. These are the general processes that are available as part of for surface engineering. As Mr. Pandey and Mr. Batra and you people said, there is innovative things coming into the market, and I'm sure it's a continuous process. More and more better processes will come, and the people who are in the business, like coating, the painting, and the alloy people, they're alloy, like with the boron doping, it gives tremendous properties enhancement. But coming to very specifically to refining or petrochemicals industry, where I come from, all this is okay for external protection, etc. We have a serious problem in dealing with the equipment and material. Example, cooling water system, where we have cooling water circulating in the heat exchangers, very common piece of equipment. And if the corrosion is not controlled there, it'll lead to downtime unexpectedly without knowing even. So it's a serious issue. Exactly the same way in the boiler. And if you are not managing the boiler's surface engineering, so again, a corrosion will set in there, and it's a very dangerous thing. How do we do this? So in case of cooling water system, because you have oxygen present there in the cooling water, water is there, and because the oxygen is in the form of dissolved oxygen, and so it's always a corrosive atmosphere prevailing there. And there, what is the primary requirement is to actually form a thin protective layer and protect the basic surface of the metal so that it is not attacked. And in order to achieve that, you have effective cooling water treatment programs, and these actually involve phosphate treatment. And that again, it's not that calcium phosphate or magnesium phosphate layer is formed purposely, and which protects the attack from the corrosive medium prevailing in the cooling water. But at the same time, you have to be clear at what level you maintain that calcium phosphate in the cooling water circulating system. And it cannot be too much. If it is too much, then you have a problem of deposition and scaling. Scaling means it affects the heat transfer coefficient. And if it is too less, then in the case of eddies or thermal shock or anything untoward happening in the system, and that layer will get away. And the moment layer goes away, that thin protective layer, and so you will have the corrosion set in. So what we need to have is a excessive phosphate quantity in the cooling water system, but maintained in a dispersion form. And so you need to provide some dispersant and to make sure that you have the phosphate quantity. Phosphate is generally maintained through trisodium. There are several phosphate we use, including the phosphonates. And with that, the phosphate level is maintained so that you neither have scaling problem nor the corrosion. Now, most important part in this is if you are leaving, when we start off this treatment program or commission the heat exchangers without taking care of preparing the surface, then it will be a disastrous result. And I can guarantee you. So that is why before you even launch a program, you need to ensure that the metal surface, the virgin original metal surface, is in absolutely clean conditions. That means no oil or grease, no rust or mill scales. So there is what is called a passivating process. You clean the water, you clean the surface with surfactants to remove the oil and grease. You clean with acid, by doing acid cleaning, pickling, etc. And then you deposit in a controlled manner but calcium phosphate and magnesium phosphate or iron phosphate on the cooling water system. That part of the commissioning is the key to a successful treatment program and to ensure that that surface is maintained in proper condition and the corrosion is avoided in future during operation. Coming to the boiler, in a cooling water system, you can say that you do this because there is always oxygen. In boiler, inside the boiler, what do? You actually work to remove the oxygen content in the boiler feed water, because for the corrosion, most important factors are you need to have metal surface, you need to have air or oxygen, which is required for making sure that there is a reaction taking place in the cathode. So you have water, air, and continuity. So in case of cooling water, we make sure that there is a film formed and it is protected. In the boiler water, what do you do? So typically in a boiler feed water, you deaerate the water, remove the dissolved oxygen totally to, I think, 2 to 4 ppb, parts per billion. So the impact of oxygen is much reduced. Again, in preparation for the boiler to have a proper corrosion control, we need to have, before we do the commissioning, make sure that there is proper alkali cleaning and surfactant cleaning to remove the oil and grease. You do acid cleaning, and then when you're commissioning, you're actually commission and form a magnetite hard deposit or a film. It's not a rust magnetite, which is one form is partially oxidized product, which is hard. Fully oxidized product is nothing but ferric oxide, which is rust. So we do not want rust to be formed. So you need a hard magnetite film formed, and that is what you do by proper treatment during the commissioning, and make sure that magnetite layer is maintained during the operation, and that maintenance is done by typically disodium or trisodium phosphate or mixture of that and a particular pH level, and ensure that it is maintained at a certain level so that it is the water doesn't get into become basic or acidic, and it's typically we maintain that the pH of the boiler water inside the boiler around 9, so that they are not corrosive. And this is typically in petrochemical and refinery industries, where you have an environment which may contain sulfur dioxide, nitrous oxide, and all kinds of impurities, etc. But if you go to a power plant, typically there is no such problem, and the water is absolutely pure. And as long as the water is very pure, you can actually manage with all volatile treatment, such as amine. And but there is no hard magnetite layer formed in those treatment programs. So these are some of the possible, I would say, as a metallurgist talks about hardening and alloying, and also the coating people talk about painting, coating, and all that. As you said, polyurethane coating, epoxy coating, and all that. But when it comes to the process industries, then we need to actually handle it in a different manner. And these are also part of the surface engineering. With that, because this is a subject which we can talk for hours and days, and every subject in the surface engineering, every sub-subject is a vast technical issue, technology involved, and a lot of innovation taking place continuously. And with that, I wish on the 2 days program a grand success, and I also wish the participants will benefit from these proceedings, and will have something to take home at the end of these conference proceedings. With that, thank you very much again, Chemtech Foundation, for giving me this opportunity. Probably I exceeded the time, and I didn't make note of the time when I started. Sorry about it. Thank you.
Thank you, sir, for your enlightening words, and also very knowledgeable, and it gives an entire perspective about the theme, about the problems, and what are the possible solutions. Thank you again. With this, we move to the next speaker for today, Dr. V.S. Raja, who is the Institute Chair Professor for Department of Metallurgical Engineering and Material Science, IIT Mumbai. When we were discussing about the theme, we had Mr. Raja's name, which came to the foremost by all the advisory members. His lecture title will be Innovative Coatings for Mitigating Corrosion in Diverse Conditions. Over to you, Mr. Raja, for your address. Mr. Raja, you are on mute. You are on mute, sir.
Good afternoon to all of you, and the distinguished panelists, and Mr. K.L. Batra, my friend, and also the organizers, Mr. Suzan Sunagar, and the convener of this program, Mr. R.P. Pandey, and Mr. Sethi, for the kind invitation for me to deliver this lecture. I hope you can hear me.
Yeah.
Okay. So it is indeed a great pleasure for me to share the kind of experience we have in developing the innovative coatings for mitigating corrosion in diverse conditions. I use the title diverse conditions because, the title of this particular conference is on surface engineering. And very nicely, Mr. Narayan has said in his inaugural lecture that surface engineering covers wide gamut of engineering the surfaces, and it is many times it is not sufficient to have just the corrosion resistance. When you give a coating, the coating need to offer resistance against multiple type of failures. Corrosion is one among the failures, and these failures can act in synergy. So what I'm going to do and today is just give you a perspective. I don't think there is enough time to talk about it. Just give you a perspective as to how, as we scientists or engineers are enamored with the diverse type of coatings available for us, how we can engineer the coatings. I also, from the in academic institution, I also going to throw some information about how we can achieve these properties by tailoring these surfaces, by understanding these surfaces. And to start with, when you talk about coating developments, traditionally we talk about the performance, how long the coating will last in a given condition, actually, given temperatures, pressures, environment, and so on. Just in cost, we talk about life cycle cost. But of late, this has become a problematic thing. A lot of things are happening over time period. The so-called excellent coatings, very, very cost-effective coatings, are not really going to be useful for us. For example, Mr. Narayan talked about inhibitors. Chromate, excellent, very cheap, but you can't use them. People talked about using phosphates, and phosphates are really having some problems. So I want to talk about some of these issues, how we evolve in our time period. Coatings having high performance, affordable cost, and also to satisfy the environmental demand regulations. Now, this has been talked to you what corrosion is all about. I just wanted to say that the corrosion, when you talk about the failure due to chemical environment, and the corrosion need not lead to a loss in structural integrity, any loss in function. As Mr. Narayan talked about, heat transfer will be a problem. Tubes are intact, no leak, but there's a problem like that. So that's one of the things. And these things are happening because you have a material, the environment, chemical environment, the design coming to pictures. There are several ways in which you can mitigate corrosion, and coating is only one of the ways of doing it. In fact, coating is one of the predominantly used methods of preventing corrosion because it is very versatile and it's easy to apply in many cases. And surface engineering, we talked about, this is creating a synergy between the substrate and the surfaces. You just have wonderful materials, like have high strength, high creep stuff, all kind of mechanical properties. They don't have good corrosion resistance. Coatings have very good corrosion resistance. An example is glass lining, right? It doesn't have any strength, any toughness, but gives excellent corrosion resistance. Applied over a simple steel surfaces can give you fantastic properties. So it is a synergy between a substrate and the surface that we are going to modify by various means. That cannot be offered, not given by any of these two in isolation, not possible. And when you talk about corrosion, it is quite diverse. I mean, the application is very important. When you talk about impeller, yes, you need to have a corrosion resistance plus impact, turbines, maybe gear, and so on and so forth. These are just a few examples. For example, gas turbines, steam turbines, they are totally different situations. So the kind of coatings that you're going to develop or apply are not going to be the same. They should have different properties. Now, this is a very old slide, so to say, 2010. I think Alan Matthews is chief editor of Surface Coating Technology. He summarized nicely what all the type of surface engineering technologies available for us. And painting, you see here, is one of the important part of this, no doubt about it. Then comes electroplating, zinc coatings. There are various other things like surface heat treatment processes. Anomaly. There are several techniques, hard phasing, for example, post in preheat treatment processes, anodizing. Several of them constitute the surface engineering processes, and many of them synergize the required properties: heat, corrosion, erosion, temperature, all kind of stuffs. Various kind of techniques available for us. Now we have a range of techniques available for you to obtain. One property which I call them as hardness property is one of the important properties whenever we talk about a structure which is having a relative motion with respect to the environment it is handling. So you need to have a high hardness. Variety of techniques we don't have time here to talk about. We can give coating thicknesses in the range of 0.1 micron to millimeters. Surface hardening, for example, well coatings, overlaying, well overlay coatings, plasma coatings, they all lie in the thick regions of this section, right? Whereas talk about plasma ion implantation, they are talking about microns or body implants, gears in watches. Of course, nowadays you don't use these kind of watches. Nitrocarburizing, a variety of things are available to us actually. Okay, and so these are the techniques. Again, as I told you, we don't have time. This I'm going to give you some kind of exposure for you to get an idea about what are the ways and means that we can achieve better surfaces to have corrosion resistance along with other required properties. Plasma nitriding is, one of the techniques very, very widely used. I just give some example here. Again, not much details. What I'm going to give in each case is one PhD student work. I'm going to give 3 slides. I'm not going to give more than that. So those I'm going to compress the work. The idea is to give you a feel for how to generate surfaces that can give you better corrosion resistance. This is plasma nitriding. One PhD student worked with us. Plasma ion immersion technique. Another student, PhD student worked on it. This is for stainless steel. Stainless steels are excellent materials for corrosion resistance, right? But then they're soft materials. Where, for example, you're going to use a wall, in a flow lines, you may not be happy with just corrosion resistance. You need to have higher hardness, higher erosion resistance. It's very important. How to do that? You use this technique. Again, we don't have much time. You can implant nitrogen into the material, like carburizing, for example. You can have nitriding processes. You can do that. You can increase the hardness very significantly, starting from 250 weakest hardness to about 2000 hardness. You see, this hardness can be significantly improved by putting nitrogen in that. Actually. But there are some issues that only we, as engineers, should be aware of. You keep increasing the hardness, you might compromise on corrosion resistance of that. So that means you need to optimize the treatment processes so that you're not going to lose corrosion resistance, or rather you're going to increase corrosion resistance and also going to increase the hardness properties. This is something which we talk about, the electrochemical polarization curve. It talks about how good it is. For example, what's shown in this curve is potential versus the current. What you see here is when I raise the potential, the current does not increase. We call them as a passive region here. See, so nice. The stainless steel has got a huge amount of passivation that taking place because of this. Again, not all the stainlesses are same, right? 316, 304, and a manganese containing stainless steel. Not all of them behave same manner. So that means you need to understand what is the constituent of these stainless steels and how effective it is when you are going to add nitrogen. Not all of them are going to be there. So we need to do deeper studies to get to know the synergy between what you add to it and then the metal that is going to be there. So this is one way of improving the corrosion resistance plus the hardness of the section. But then the thickness of these coatings are very small and not very large. For example, you can go for body implants, small coating thickness, fine. But I want to talk about the gearboxes where the thickness of the coating is quite large. Then plasma ion implantation will not work. Then you go for plasma nitriding technique. That is there in the Plasma Institute in Gujarat. In fact, it has been helping aerospace industries, even oil and gas industries, thermal industries, nuclear industries, for example, they're helping to a large extent to convert the surface into a hard surface and corrosion systems. You see here kind of coatings, you can call it nitriding processes. This is called plasma nitriding, and this is called plasma nitrocarburizing. Okay, so that's what you can do that, right? So you can get the hard surfaces here, and these hard surfaces have unique properties of hardness as well as the corrosion resistance. I can increase the hardness values, okay, but again, there are various operating conditions, temperatures, concentration of the species that are going to add to it. A lot of variations are going to be there. The net cell, it is possible to tailor the surface to have different hardness values, and then a corresponding change in the corrosion resistance of the section. It's possible. Again, we go into details about understanding the phase transformations, whether nitrogen is in solid form, whether it's forming a carbides and nitrides, all kind of stuff. So we're going to look at it. If you don't do a proper thing, it can be disastrous. You can have nitride, you can have pitting temperature. So you can optimize it study them in details, get them optimized properties. So that is about stainless steels. Now we look at materials. Now, just now, I think probably Mr. Pandey was talking about titanium, aluminum, magnesium. These are very good materials, but they're very soft. How do I improve the hardness properties of this? In case, if you do this technique, the hardness of the surface can be as good as boron nitride. And you know, boron nitride is one of the hardest things, very close to diamond, right? I can increase the hardness of this by using a non-conventional anodizing process. We call them as plasma electrolytic oxidation process. It's very, very simple, environmental friendly. You know, you don't add any chemicals. You know, very few chemicals are added to it. You just get a very, very hard layer. Look at the layer here, very thick aluminum oxide layer. It's formed, and this layer has got hardness, which is very close to boron nitride, very close to diamond. And correspondingly, the corrosion resistance is significantly improved. Look at the current here. What you see here, the potential versus current. There's a few order of decrease in the current is taking place because of this coating. What more you want? You want a very high hardness. You have excellent corrosion resistance obtained for very soft material like aluminum. This case is a magnesium alloy actually. So you can get these kind of properties. So that is about surface conversion coatings. Let me go to some examples of metallic coatings. We all know about hot dip galvanizing, right? Very, very well-known things. People talk about pure zinc. And pure zinc coating is not really pure. It has got about 1% aluminum is there actually. For various metallurgical reasons, they add this. And this is very widely used. But then you can significantly increase the corrosion resistance by alloying with aluminum, like 5-8% aluminum called Galvalum, 55-8%. And we talk about, Mr. Pandey was talking about offshore conditions. Excellent coatings, offshore conditions. Galvalum is excellent corrosion resistance material actually. For automobiles, they've been talking about it. We talk about zinc, aluminum, magnesium coating. It gives you 5 to 6 times more corrosion resistance than this one by adding aluminum and magnesium. Superior coatings are being developed by changing the metallurgical properties. Again, I'm just giving you only illustrations. I don't have time to go into details. One of the important things when we talk about zinc coatings is the life of this, the service life of these zinc coatings is related to coating thickness, right? When the coating thickness increases, the service life increases. But that is very interesting that we know about it. But look at the steel industry. The steel industry has to increase the thickness of this by 1 micron. For example, let's take Tata Steel. It has to increase 1 micron thickness of zinc, spend a few crores, maybe about 20-30 crores annually. They have to spend more money for the same coatings. Can we reduce the thickness? Can we improve the properties? Can we have better properties? Because we have no resources of zinc. And zinc is increasing the cost and so on. So can we have thin coatings and have excellent corrosion resistance? And that's where you see here. The example in this left-hand side diagram is average corrosion loss versus exposure time. Zinc is you see the loss in corrosion, and you have zinc aluminum, and you have aluminum here. Aluminum, of course, is a problem, pure aluminum. Sometimes it can backfire, giving rise to galvanic corrosions. What we have done in our own lab, in a PhD student, it has been now patented, and we have now transferring this technology to Tata Steel soon, is to develop an alloy wherein you add just about 0.028% element, only that much, right? You can bring down the corrosion resistance so significantly. I'm giving you only a simple diagram for you to appreciate it now. This is for pure zinc. This is the zinc normal, hot dip galvanizing coatings, alloy A, alloy B coatings, 0.028% only element added. Look at this, 168 hours rusting here. Now 552, no rusting taking place. Look at the kind of increase. Not only 552, you can look at this, it has reached almost 1056 hours, and you don't see much increase in the corrosion of these coatings. So you can simply tweak it by adding small element. How does it happen? This is the kind of visual pictures that you see here, but see them in the microscope. You see a significant change in terms of the microstructure in these alloys. And this is what we call as a grain size refinement taking place. And this refinement has given enormous resistance to the corrosion. That means you can imagine that same thickness of the coating, life is increased by 5 times, 6 times. Wonderful thing to save resources, and it gives you better properties of this actually. In fact, these coatings, they do not give you, this gives you a mirror-like finish. The appearance is really wonderful actually. And again, the grind size, I'm going to skip. I know the time is going to be short, so I'm not going to talk about more on that. Let me now come to the topic very close to many of you. We talk about paint coatings. The paint coating is one of the problematic coatings. Of course, very versatile. I don't think there's any coating which is as versatile as a paint coating. Actually, it's just easy to apply. But over the time period, a lot of legislations. The olden days, people talk about chromating, then comes the phasedating. Now even phasedating is being replaced. That means we talk about some kind of primer coatings where you don't want chromates, you don't want phasedates. So people talk about coatings based on silane-based coatings. We have done this work. This Faraz Gaonkar, a doctor, postdoc candidate in our place, we've done actually. It's an eco-friendly coating, simply silane, silica. Silica is to be as friendly as possible, because you have a lot of sand, so it's environmental friendly. Of course, you need to modify with various kind of ingredients you add to it actually. You add this and you can add more. Now, what I was talking about is, in Europe, for example, phosphate is now known. Just not only chromate, because phosphate is a good nutrient, right, for the plants. So you can see this eutrophication is a problem for pure water resources. So that means the challenges are more as the technology becoming more and more developed, as the resources are being shrinking, and there are a lot of legislation to not use the normal coatings for that. So this is the kind of work that we have done. It's work done with the Tata Steel at Europe. We undertook a work on it. Now, one of the things that we talk about is you can never forget science, right? Now we look at the elements which are going to be very close in terms of properties, like a phosphate or maybe chromate, for example. You look at some elements. These elements are like titanium, niobium, zirconium, lanthanum, and so on. So you look at incorporating these oxides into the paint systems and see whether we can improve this property of this here. So this is one of the work that we have done actually, and so that was one work that is done for the automobile industry, because automobile industry is one of the polluting industry. A lot of in fact, that is one of the real problems in terms of pollution as compared to other industries. So silane coatings, again, we can look at various types of silanes, the stability of the silanes, their ability to hydrolyze, the temperature resistance, all kind of stuffs. Again, these silane coatings sometimes can crack. You add some nanoparticles, you add some cerium, because cerium gives you something like intelligent element to reduce the corrosion whenever there's a crack occurs. So these are the kind of things, they look at this coating. They are very, very thin coatings. It's very transparent coating, for example, and we can add various kinds of additives in order to improve the performance of this actually. Okay, again, visual observations, and see, these are it's like a lacquer, you see. You can have a transparent coating, and then you can have an excellent corrosion resistance. This is called as impedance plot, board plot, we call it actually. 10%. Look at the normal coating, normal, uncoated mild steels. It's about 10 ohm centimeter square, 10 per 5 ohm centimeter square. So that is the kind of high orders of resistance is increased because of these coatings. Again, excuse me, because I'm not going to details, no time. I'm just trying to illustrate to you how you can develop newer coatings, which also complies with the environment actually, and also can give you better performance. Now, come to, let's say, paint coating, so-called polymer coatings. I give you some 2 examples, then I close my talk. Now, we all talk about VOC. Now, that's why we talk about water-based coatings now, actually. Can we really use the so-called polymer coatings and try to avoid VOC, volatile organic compounds? How much you can eliminate physics? So this is one of the work of our PhD student. It is done by, it's also part of naval work by DRDO laboratory. Now, this is basically utilize low density polyethylene, and Ms. Batra will know that low density polyethylene is very good, but then it cannot bond so nice. It's not having a polar group, right? It doesn't have a polar group. The bonding is not going to be so great. So what we do is that we take this low density polyethylene and then graft a molecule that will form a bond with this molecule, and which in turn will bond with metal surface, right? So you can grab this in space. I'll show you later actually, so that this molecule can be made into polar molecule, and that polar molecule is going to form a bond. Now, what the advantage of this? This low density polyethylene granules, you can do a thermal spray now. You can do a thermal spray. And when you do a thermal spray, they don't decompose. Very nice. They melt it and form a kind of compound. Now look at, this is the kind of comparison between the cost and VOC and all. We don't have time. I can share the slides with you later. All I'd like to say is that cost is good. It has good life, low VOC. That's the kind of thing. And then of course, this is a kind of way that you can change the technology of applying the coating itself actually. Now, as I told you, we start with the low density polyethylene, and you tweak the molecule by grafting it with malic anhydride, malic acid you call it, because malic acid has got a polar group. You just incorporate that into this molecule, and then what happens? That becomes a polar group. The polar group gives you what is called as a bonding with the metal surfaces, and then apply the flame. So there are a series of methodologies people use. There are various ways where we are grafting it. You can graft it using extrusion thing. You can graft it using gamma radiations. We finally did with the extrusion process actually, so that you can blend it very nicely. And of course, we need to understand the molecule. What really happens is when you're going to graft it, as that anhydride gone to the molecule now, yes, it has gone to the molecule to show that yes, there is a change in the hydroxyl group taking place. You can reconfirm this in terms of looking at the acid values. LDPE 0.6, LDPE malic acid grafted is, you can see 8.9. So it means there is a component of malic acid which is being grafted into the molecule, actually, the polymer molecules. So we can also look at it. Now again, when you do a thermal spray, it should not decompose, right? It decomposes, everything is gone. So you look at this spectrum, the IR spectrum there, before and after that, and see that, yeah, they're looking good. I mean, there's not much of a problem, and there's no decomposition. Of course, we need to optimize the temperatures, we need to optimize everything. Otherwise, you can burn. I mean, obviously, you can burn. So we need to optimize the process conditions so that it is going to be just melting and forming coating and all. It is just not enough to develop a molecule. You need to look at the characterization. For example, you have a polymer. How does it resist corrosion? It doesn't allow the water permeation, right? So we look at what is how much of water is getting permeated into systems. So you can use various techniques. One technique is IR spectroscopy. We use impedance spectroscopy to determine the amount of water that is being converted into that. So we also follow these peaks over here, which are indication of to what extent the polymer is getting degraded with time. Now, you can quantify the corrosion resistance properties. Look at this value here. It is called as polarization resistance offered by the coating for the flow of current. Yeah, Mr. B. Narayan talk about current has to flow, right? How does this coating offer resistance? You can see this coating here. The 10 power 10 ohm centimeter square. It's a phenomenally increasing thing here now. So this thing can happen, okay, because of the grafting of the coating. Of course, this has been added with what you call red oxide. Pigments are being added to this particular coating. Into that, again, you can determine the amount of water that is getting permeated, right? We can do this kind of things. You can see that, in fact, it's very interesting now. The water permeation in this coating changes with the pigment concentration. At this concentration, the pigment, the water permeation becomes the least. You can start increasing. Of course, there are science behind it in terms of how the pigment itself becomes a path for channeling and so on and so forth. Okay, so up to this level, it becomes a block, and beyond this, they themselves forms a continuous path for the water flow into the coating at all, actually. So this is the proof of the pudding is in eating. Then you look at these coatings, put them to salt spray and see what happens at all, and look at the blister formation in a salt fog test. Okay, we have various kinds of pigments, titanium dioxide, and you have MiO, you can use aluminum. Various type of pigments are being added to it to determine the performance of these coatings. This is a kind of don't worry about this table here. This only tells you that we have done a detailed studies in terms of salt spray, seawater immersion, humidity, because the performance of the coating in salt spray, salt fog is different from the immersion conditions, right? So we just look at what are the ways that it's getting performance is done here. This is in terms of scale. These are all published, and I can share the data with you. You can go through them very, very leisurely. Very interesting thing about is that the kind of pigment that you add to it plays an important role. I think one of the distinguished panel members talked about nano, right? These nano pigments is very important. We just looked at the role of nano clay composite, close at 20, right? It's a clay actually. And when you add this clay, look at the water absorption. Look at this y-axis, volume of water absorption versus exposure days. This gives you the lowest amount of water absorption here. That is due to the addition of the clay here, right? The clay addition reduces the water absorption and so the performance of the coatings. And this has been now proven. This coating has been applied and shown, and we have also been published here actually. So this is a technique, a technology. It's developed in India for Indian applications now, and this is eco-friendly coating, and it's very, very economical coating as well. I have two more topics. I think let the chairman please let me know when I need to finish it. Give me just 5 minutes time, and so that I can wind up my talk. See, it is very important that we understand the molecule and try to tweak it so that you get the required properties. I give an example. This is the PhD work of Rasmi David, my student. She's finished PhD and is working now. Now, Mr. Badr was talking about in 1980s or 90s, people talk about epoxy-based coatings. Epoxy coatings are wonderful coatings at all. But one of the problems with epoxy coating, typical epoxy coatings are they are brittle. The toughness of these coatings are going to be not very high. I don't think I need to talk about the importance of the coatings, how it's being applied. It is applied by two-pack resin processes. I will not go into details about this one. Let me just go into what our work is and how it fits into multi-requirements. And this is related to submarine applications, underwater applications. Now, when you talk about, cases where you talk about splash zone, we talk about cargoes or, platforms, and we talk about, the cases where constant impingement is taking place, the paint has to last its life before it can protect for longer time. Okay, so it is necessary to have corrosion resistance, necessary to have chemical resistance. It is important to have mechanical resistance, especially toughness. And the epoxy coatings are not known for that. So how do you really modify this? The epoxy has a very strong cross-linking, right? When you have more cross-linking, it's very rigid, no doubt about it. It's not tough part. So how to do that? You just get into fundamental aspect of it. We borrowed something from the aerospace industry where people use polysulfide, right? Polysulfide is linear chain polysulfide is used. It's an elastomer, for example, right? It is used as a gasket and so on. So can we incorporate this polysulfide into the epoxy? Okay? Can we incorporate carboxylic terminated polyethylene glycol adipiate? Now we synthesize this particular CTPA. We synthesize again carboxylic terminated polyethylene glycol succinate. We synthesize these compounds and then we cross-link along with the normal epoxy actually. What is the advantage? These are linear chains. They are almost aliphatic now. So that means you have a combination which is aliphatic, which is having a good, resilience. In this case, for example, you have here, whereas aromatic, you have much more cross-linking. You have brittle structures. So you can put them together, then the molecule will have a better toughness. And I'll show you some of the data that we have got from this now. And again, you can see how by modifying this, again, systematic work, various proportions of these additives are being added, and then the corrosion resistance are being determined in this case actually. Okay, so again, this is the plots of this is unmodified epoxies and modified with these two things. Please look at this is after about 1,000 hours of exposure, right? About 1,000 hours of exposure, you still have 10 power 6 impedance actually in that. That means it's really good. It's really good, and so the performance of this is certainly very good, no problem, okay, in terms of corrosion resistance. And again, of course, this summarizes the data that you see here, right? What you see here in this, the case is, you can see that the resistance of this coating versus the immersion time, you can see this 10 power 9, the decay is not going to be that sharp, okay? And the neat epoxy, you can see that there's a sharp decay in terms of resistance here, right? So the modification of this molecule with these additives now, I think, has given rise to a significant improvement in the corrosion performance of the epoxy now. There are something like breakpoint frequency, too much of science. I will not, dwell on it actually, but these are some of the techniques which are useful to really understand the coating properties without taking into consideration thickness. You need to normalize. For example, you have panels of different thicknesses. Obviously, the performance is going to be different. Can you have a parameter which will take into account, for example, the thickness? That is called as the breakpoint frequency. You take this value and then try to understand how the performance of the coating is really changing. Okay, so among all these coatings, this is adipic acid has given us to have better properties than this actually. Now, these are the data with respect to the elongation. Please see here, the elongation of this particular polymers. This is all, the freestanding films, epoxies. Look at this now. This is the elongation to break, tensile strength, right? Now you see this elongation to break. This is your, this is modified polymers. So look at this here. Now the elongation has increased from 87% to 168% here. That means it's having really good toughness as compared to neat epoxies. Of course, when I'm going to increase the elongation, you're going to lose on strength. Of course, strength is going to be lost. But in this case, you can see here, the strength is still better as compared to the other two modifications. Well, I just want to touch upon last, if there's a time permits. When we talk about coatings, many times we talk about coatings for ambient temperature applications, actually. Or we talk about elevated temperature applications. Elevated means we talk about 200 or something like that, actually. But there are temperatures like gas turbine applications. Whole lot of technology. In fact, the technology is so highly advanced in terms of developing coatings for gas turbine engines. And these are very important because the efficiency of these engines depend upon the operating temperature of these engines. If temperature goes up, then of course there's a creep problem, oxidation problem, so on and so forth. The coating should have thermal barrier, corrosion resistance, shock resistance, all put them together. Now, over the years, again, it's not a very recent slide, it's around 2000 years, the increased temperature of operation. You can see this here, over from 1960 now to that, about 250 degrees Celsius is a rise in temperature of these turbines being operated now. So that's a kind of advantage of having these coatings. But these coatings are developed by plasma spray electron beam processes. Each of them have advantage. I have about 3 to 4 students work on it actually, but I just again give you only one slide to show how important it is to develop a technology that will have better performance. These are all the turbine blades that we talk about, gas turbine blades, and this is coated with an oxide coatings. There's a thermal mismatch between this metal and oxide coatings. In order to reduce the thermal strains, you have a bond coating, which is having a coefficient of thermal expansion lies between this oxide coating, the metal coating here, it's a bond coat, and this gives you a nice graded performance from the point of view of thermal expansions. Now, the point here is when you're going to cycle the temperatures and there is going to be strain involved in these coatings, that means the strain has to be tolerated. How do you tolerate the strain? You tolerate the strain by growing these oxides in a columnar manner. Please look at this. There is aligned growth of these oxides. And because of this aligned growth, when they start moving like that, the strain is now taken care of. They don't really break. But then there are some issues here because these grains allow the corrosion liquid go inside. There are some problems. Okay. So that happens. So how do you really modify this? We worked with ARCA Hyderabad and to modify some of the coatings. Oh, I didn't have this slide here. It is called as solution precursor plasma coatings, for example, that gives you better stain tolerance, better resistance against oxidation, sulfidation, hot corrosion, so on and so forth. This is a big topic by itself. Okay, it's not having time to do that. But all I'm trying to say is that sky is the limit. I mean, you just only have to apply the technology in order to develop coatings and surfaces that will have far-reaching properties. So I think I need to be thanking or acknowledging the many of the students here. Several of them are not given here. Mostly we are given only PhD guys who are all contributed to this. There are several funding agencies. Main funding agency was the Department of Science and Technology. So with this, I would like to end my talk. And again, I would like to thank the organizers for the kind invitation. I do hope that this lecture gives you some kind of exposure to the diverse coatings, the diverse technologies that are available to solve the myriad problems, various kind of components face in real life situations. So thank you again. If you have any questions, I'll be happy to answer. Thank you.
Thank you, sir, for a wonderful address, and it was really very enlightening. Sir, can you unshare the screen?
Yes.
We take the questions later on. Thank you very much for your wonderful address and giving the entire perspective about corrosion and various challenges and how to overcome it. Now, I would request our closing remarks by Mr. Sanjay Chaudhary, Business Head, Protected Berger Paints, and he is also the Technical Committee Head. Mr. Sanjay Chaudhary has over 27 years experience in the field of corrosion mitigation. He is the chairman of US SSPC for India subcontinent, member of NACE, CIA, and others. So with this, I would like to invite Mr. Chaudhary to give his closing remarks for the inaugural session. Thank you, Mr. Chaudhary, and over to you.
Yeah, warm welcome and cherished afternoon to all of our distinguished panelists, honorable dignitaries, speakers, organizers, and sponsors, and my dearest participants and delegates. It's a great privilege for me to propose the vote of thanks and closing remarks, and acknowledging the contribution to the area who worked hard to make the conference successful, and creating a platform where we can at least share our views and understand what is the pain area and how we can take it up in the next level. This type of event cannot happen overnight. The wheels were started moving because initially that idea of innovation through collaboration in reducing the corrosion in oil and gas and power industry, it was derived after a long debate and deliberation, and it was the need of the hour. And I am thankful to Mr. R.P. Pandey for his active participation in deriving that name. So we are fortunate enough to be supported by a team which is very, very active, passionate, and dedicated. And this team has basically proved that that event can be successful. And it's a real team effort. And it is a lack of word I am having that their willingness to take the task beyond their comfort zone. It was not easy job. The special mention to Mr. Batra, Mr. Hemant Sethi, and continuous Mr. Nagar, who are basically pushing everybody, and the garland was created by them, and they inspire us to do their best and stands as a pillar of power. So that's how this event has come to a shape. With a deep sense of appreciation, I would like to thank Mr. Pandey once again. I would like to thank the group president and Mr. Honorable Mr. B. Narayan, our professor, Dr. V.S. Raja, for giving wonderful insight on the corrosion subject. I am in this process for a very long time for the corrosion mitigation technique. And I have found that there is a very big gap in the area of application, in the area of understanding mitigation, and that's how there is a huge loss. So it is not only the coating per se, it is surface engineering also playing a very critical role, which has been shown by Dr. Raja in his, so it is an eye opener for everybody. And so there is so much of work can be done in this particular area. So this, I would like to conclude that this type of initiative will not only help us to bridge the gap and create a paradigm shift in understanding the corrosion protection through innovation. This can be only achieved with the collaboration among each other. It is the institute or industry collaboration or understanding the customer requirement, and that collaboration need to be communicated through this platform. That this is what is happening, and this is what industry requires, and this is where our direction should be, and we should work towards that. And third one, there should be a commitment to really take it up in a very enthusiastic manner, and that type of today's participation itself indicates that type of commitment is there. So let us take it up for the next level to keep this tempo high to save our national assets, which is basically eroding 3.5% of our GDP because of non-mitigation knowledge of the corrosion. So with that note, I can tell you big thanks to all of you, and let this event successful. Let us having a lot of panel, a lot of conferences, a lot of new topics will be discussed, and it should be a really value addition for each and everybody. Thank you once again. Thanks a lot.
Thank you, Mr. Chaudhary, for closing today's inaugural session. With this, we come to the end of the inaugural session of Surface Engineering and Corrosion Control. It was wonderful to interact with all of everybody. We would like to thank Batra sir, RP Pandey sir, Mr. V.S. Raja sir, B. Narayan sir, and Mr. Chaudhary for letting the ball roll and setting the theme for the coming sessions. Thank you all. And now we would like to move over to the next session which is on protective coating system for oil and gas and power industry. And we would like to once again thank all our panelists and also the delegates who are there and posing questions. Thank you all. Thank you, sir, for being part of today's.
Thank you so much, all of you. Thank you, Narayan sir. Thank you so much.
Thank you.
Thank you.
Thank you, Hemant.
Thank you.
Thank you, sir.
Thank you, Mr. Raja.
Thank you. Now we will move over to the next session. We have already the panelists who have already joined for the second session, which is on protective coating systems for oil, gas, and power industry. We have Mr. Ravi Mohan Dabral, Business Development Director, Europe and CEO, India, OCSL, Europe. We have Mr. Anand Kumar Tiwari, Retired Executive Director, Operations of Indian Oil Corporations Limited, Pipeline Division, Noida. Mr. Sachin Joshi, CEO, Greenova Specialty Coatings. We have Mr. Mahesh Kumar Aradhya, Associate Vice President R&D of Grower and Well. We will have Mr. Merrick Elpert, Eon Coat LLC. He will join all the way from North Carolina, USA. So we have asked him to join around after 5, because it will be very morning hours in US. And we have Mr. Manoj Akhil from Ami Polymers. So before we move over to the start of the sessions, we would like to welcome all the panelists for the second session. So with this, I would like to introduce Mr. Ravi Mohan Dabral, who has more than 16 years of experience in advanced materials sector, and he has been responsible for establishing and promoting OCL's business in Europe, India, Middle East, and Singapore for the last 6 years. And he has also been part of the Chemtech series, which we conducted in Hyderabad. Thank you, Mr. Dabral, and I will now move over and hand over the session to you for your address.
Thank you so much, Mr. Nagar, and thank you so much, eminent co-panelists, for giving your time on this exhibition and discussion. I would try not to repeat what has already been said or what I cannot add value to mostly about corrosion, but as a fun fact, I would like to mention that there are a few estimates that after war, corrosion is the second most expensive activity. Corrosion prevention is the second most expensive activity that human beings do. Quite fascinating. And that does not include the damage which happens due to corrosion. That is in terms of the oil spills, lives lost, man hours lost, and all those things. Well, where corrosion hurts most is not in automobile industry or any general electrical industry. Where it hurts most, surprisingly, is oil, gas, and power industry in its operations, in its safety, and from an environmental point of view. So it does create an impact from financial point of view, and as the world is moving towards more sustainability in sustainability or environment and health point of view, which cannot be counted in terms of dollars really, or any kind of money. Yeah, I have been working mostly in innovation, innovative products, advanced material throughout the last 16 years. And what I can say from my small experience in this field is innovation. Usually the idea is it gets conceived in one mind, in singularity, but the birth is given by a group. It's never a single person or a single company that can do and execute any innovation. The industry or the whole value chain has to be a part of it. So similarly, if there is a case of an innovation for corrosion protection, it is not the formulator or the chemist or the paint producing company or even the applicator who can make that innovation a success. It has to be a whole value chain, right from the people who conceive the idea, right from the chemist who make the formulation, to the people who are using it, to the people who are paying for it, and also the people who approve it. So the standards as well as the formulations needs to go hand in hand. If the standards are 30-year-old, like the exam would be the student. If you check the mathematics of 30-year-old, you would get the answer of 30-year-old. So all need to be changed together. And that is where these kind of panels have the most value, because it brings people together from all part of the value chain. See, I come from an additive side. We don't even produce paint. We produce something called as graphene. So we can't even produce paint, let alone apply paint or change the standards by which paints are selected. By the help of this forum, me and my eminent co-panelists today would try to put forward our point that how we can innovate and how we can use the latest in technology together and bring it onto the table, onto the real life in terms of by using this brainstorming. Thank you so much. Without further ado, I would give this platform to the next speaker. Mr. Sudhanshu, could you announce it?
Yes. Thank you, Mr. Dabral, for your opening remarks for the session. Now I would like to invite Dr. Anand Kumar Tiwari, retired Executive Director Operations of Indian Oil Corporations Limited, Pipeline Division of Noida, a mechanical engineer having over 39 years of experience in the field of oil and gas and pipelines, design, technical services, project execution, operation, HSE, contracting, and budgeting. So with this, I would like to invite Mr. Tiwari for his keynote address. Thank you, sir.
Thank you, Mr. Sudhanshu. Thank you very much. I'll make a small screen sharing with some presentation too.
Okay. You can share, sir.
Are you able to get it? Are you able to see my presentation? Mr. Sudhanshu, are you able to see my presentation?
We can see, sir.
So thank you very much. First of all, my congratulations and compliments to the organizing team and for giving me the opportunity, and my fellow speakers. I must compliment Mr. Sachin Joshi, Mr. Ravi Dabral, who just spoke, and Mahesh Aradhya and others. And definitely, I'll not be talking about a particular coating and a specialist of coating, because the panel is already a very specialist panel here. Only thing I would like to highlight about the general aspect of the coating, what we are concerned with that. As per you already have debated, Mr. Dabral has said about the cost of the corrosion or something like that. So that's once it comes to the level of NACE, as per the NACE, a reputed body conducted, and it takes about that 3.4% of the global GDP for cost of the corrosion, and 4.2% for in country like India. So definitely it speaks. I was associated with the study when working with the Indian Oil with the SNES study. I underline that it's a very high figure. So definitely it calls for the corrosion. Here I have indicated in a brief this thing, that what is the process of corrosion electrochemical, and then from ore we start, and we have a tendency of metal to going back to the ore stage, and in between we require a continuous energy addition in forms of a coating or other methods. Protective coating, when we talk of oil and gas and everything, possibly from upstream oil sector, as we know that right from upstream we explore it, and then midstream sector we transport, store, and through the system, through intercountry, intercontinental movement, and then we downstream industry refinery processes and distribute as a petroleum product to you. And of course, everybody is every day hearing the news of the diesel and petrol crossing rupees 100. So definitely you all are aware of the sensitivity of these petroleum products. India has a vast coastline, 7,600 kilometers. 7,000 figure is old. Of course, I have taken it from the site only. This is an old corrosion map, but it gives a fairly good idea about the only one aspect, that while we are having 7,500 kilometer long coastline, and coastline facilitates your import of crude oil, import of natural gas in LNG form, and import of LPG, because 85% of the crude oil your country is importing, 50% LNG, and 50% LPG too. LPG growth has already been driven, particularly Pradhan Mantri Ujjwala Yojana has was one of the trigger for that, and definitely once you are, and a lot of power industries also along that, and a lot of other industries also along that. And if you see the extreme severe corrosion area is the coastal area. We'll like go through this slide, possibly if you go into that C5, that is the highest saline coastal area, about 80 to 200 micrometer per year is the corrosion load. These are ISO 12944 findings, not my own. So coastal area is highly corrosive, and Himalaya, if you see the previous slide, Himalaya becomes the least corrosive. So in between the entire country lies, and definitely a coating has a very important role to play for prevention of corrosion, because it's a barrier between substrate and a harsh environment. If the coating is effective, a large scale prevention of the corrosion can be affected in our industry, and particularly it becomes very, very vital when we are talking of oil and gas and power. Both are the crucial infrastructure industry. Their reliability, their sustainability, and the consequence of their losses and failures are very high. That's why it assumes a greater significance too. When we talk of oil and gas, right from upstream oil head to wellhead to the well casing, tubing, flow line, storage system, everywhere we have to come across the various type of coating. Midstream in transportation and handling, tankages, barges, tankages, and so many other vessels and all those things. So definitely we require a protection from a harsh environment of the high H2S, high sulfur, high carbon dioxide, high water content, crude oil, and all those things. And then downstream sector, refinery and petrochemical, where not only the medium ambient temperature, but the high temperature corrosion and other things are also the reality in presence of various gases, various catalysts, various acidic environment, various alkaline environment. So definitely the corrosion prevention becomes very, very vital. Coating in every aspect plays a very, very vital role in the even the equipment coating, like compressor coating, vessel coating, heat exchanger coating, turbine blade coating, pump coating, internals of the pump coating, that significantly improve the performance of that. So that's why the coating is a subject which is inventing, continuously innovating, and a lot of new additions are taking place. Here I have talked about the basic classifications like barrier coating, innovative coating, because metals are highly corrosive. Sometimes it's a particularly pipeline or refinery column or something like that, where we are processing a corrosive materials in that, or pipeline, the corrosive crude oil or corrosive petroleum product like naphtha is flowing through that system. We put a corrosion inhibitor. The inhibitor forms a internal coating in the pipeline system. It allows that the metal is not getting disturbed with that and with the flowing liquid, but definitely the NBT coating does react with the metal and water gets penetrated. So these are the challenges. And certain sacrificial type coating like thermal spray coatings and all those things becoming very, very common. And in fact, in my coastal areas particularly, eastern portion of the coast like Paradip and all, we have gone for the aluminum thermal spray coating for our tank roof, because tankages which are storing the crude oil or petroleum products for transportation and distribution throughout the country in a coastal area, definitely the corrosion prevention becomes very, very vital. And definitely a lot of changes and improvement has taken place, but still it's an area of challenge. Here we talk of the functionality. Physiochemical properties, you all know that corrosion protection by thermal, self-healing, anti-fouling, fire resistant and all those things. Fire resistant has a very limited application, but we do have in case of for my LPG tankages and all. And the mechanical properties where the fire could be retarded for a certain period of time. And mechanical properties are very clear to everyone that the wear resistant, abrasion, and these are the qualities we are looking in the coating, including the hardness of that. And of course, insulating, conducting coating, because say pipeline scenario, a cross country pipeline which is distributing the petroleum product throughout the country. Your country has at present about 48,000 kilometer of pipeline, and the industry is continuously expanding, particularly for the gas based economy. And we are constructing the pipeline within 3 years period will be touching about 80,000 kilometer of the cross country oil and gas piggable pipeline. There are so many other flow lines and jetty lines and other things which I'm not counting. Even the cross country piggable pipelines, they are itself is going. And definitely a lot of changes have taken place. Initially when we started our career, it was a CTE coating, and definitely that coating was not very good coating. Definitely over the period of time we have FB coating, 3-layer polythene coating, other coating materials which are much better than that, and we are using. So these are the continuously evolving process. And definitely once we talk of evolving process, the cost aspect and economy aspect also matters a lot. Here I'm talking about the coatings. If we write from power industry, right from power generation, be it your heat exchangers, your columns, your transmission distribution line, or cooling towers, stacks, turbine blades, another component of distribution and system like conductors and associated devices, all requires a various type of coatings. And type of coating which we historically using is continuously evolving and changing. So this is the area where a dynamic movement is involved, and not only the essentiality aspect of that, but it has a tremendous growth potential too. Here, definitely, when we talk of the coating, with high temperature coating becomes a very, very challenging aspect for the coating industry in general, particularly boiler piping, steam, exchanger, columns, and other high temperature application where we go for that. External corrosive and normal saline environment. I talked about the coastal area, which is C5 category as per IS code, and highly corrosive category. What type of a corrosion protection through coating we can go for that. Subsoil application like underground pipeline. I talked about the growth industry of the pipeline, which is likely to touch 80,000 kilometer within a period of few years, against the 50,000, close to 50,000 now. But these underground pipelines are facing the hostile soil environment at every moment, every inch of the pipeline. Only the barrier coating, that is insulated coating on the pipeline, and then additionally the cathodic protection system is protecting the pipeline. So definitely the coating becomes a primary barrier between a hostile soil as well as the metal, which is in the ground, which has every tendency of getting corroded. So the coating assumes a greater significance in terms of its reliability and performance. Above ground pipelines, plant piping structure in a corrosive environment where H2S could be there, dust could be there. Dust is another enemy of the coating, particularly in the western area and eastern coast area. In my tankages and other structure, we find that because the abrasion taking place in the coating because of the high wind velocity accompanied with the dust. Coating for turbine blades, even the renewable energy areas, whether we talk of a solar energy or wind turbines, the coating assumes a greater significance either in the wind blades or solar power system or PV cells and all those things. This becomes a very, very vital aspect of that. Right from well tubing to flow lines to separators to filter, scrubber, tanks and associated structure, everywhere the coating is essential aspect of the oil and gas industry. We classify, there could be various classification of the coating. So I'm talking to the experts, so I'm not going into details. I'm just indicating what type of possibly we come across, like metallic, non-metallic, and composite also coming in a big way. polyurethane, epoxy, alkylate, zinc-rich, acrylic, other thermal spray coating. This is assuming a greater significance, particularly for the coastal line area tankages and roof and other structures. But it's very costly, of course. I'm sure over the period of time, the cost will come down with innovative efforts are being made. Ceramic coating, very hard coating, possibly we require an application like some blades or something like that, where continuously they are facing the air resistance or dynamic wear properties. And nanomaterial based coating are the new supplement to that, and they're finding its place in the society. Don't worry, Sudhanshu, I'll be completing as per the time allotted to me. I will not be exceeding the time limit. Anti-corrosion coating, when we talk of a coating, is not limited to oil and gas and power sector. It was, I think, entire domain of activity. Couple of years back, I was the National Corrosion Council of India chairperson. I organized a seminar on the corrosion at Bhubaneswar, which was inaugurated by then Petroleum Minister, and where entire industry participated, be it automobiles, be it paint manufacturers, be it shipping industry, government sectors, defense industry, everybody, aeroscope industry, apart from the oil and gas and power, everybody participated, and they expressed the concern about the kind of problems they are facing in the corrosion and what type of a coating they are looking for. Challenges of the coating, if we talk of that, proper formulation, selection of a suitable coating, because one type of coating cannot be suitable for everywhere. Even in my subsoil environment of pipeline also, similar type of coating is not suitable for everywhere. Preparation of a surface, because any coating application, the efficacy depends on the preparation of surface. So definitely that assumes a greater significance. Always we cannot go for SA 2.5 and all those things, level of cleanness. What should be the method, alternate method? Methodology of application, because it's dependent on how we are applying that. And our NACE has some certification courses and other international course talk about the methodology of application, national application, but definitely it's a very wide subject for the industry. What is the curing and drying methodology? How to face the hostile environment like S2S, high temperature, dust, etc. And corrosion under insulation and effective protection. This also really a challenge. What type of coating we should be going for that? Because certain areas because that we wanted to protect the temperature, so that we go for a insulation of piping, be it a gas piping, be it oil and gas piping, or be it a steam piping. So corrosion takes place. What type of coating the bare pipe should have prior to putting the insulation on that? Internal coating of pipeline. This actually I wanted to talk a little bit more about that, because internal coating, when I'm talking to a pipeline, one pipeline length is general. I'm talking of API 5L grade pipeline, high steel grade pipeline. Length is 10 to 11 meter. But pipelines are welded. Internal coating, some of the gas companies have gone, even including IOC has gone, but its own challenges. Because if you put the internal coating, cut back length, you are towards the weld area, you are leaving the coating. Because if you put any coating, during the welding of the pipeline, the coating will get damaged. And because of the above ground piping, like water piping or something like that, industry is using internal coating, because there we are having the flange end, and we put the flange and then we go for a coating. For a cross country pipeline, where the pipelines one to another is welded, still is a challenge. I am posing it to the my respected colleague. Possibly they can think of that. And of course, the training and workforce for the application of coating assumes a greater significance, because every Tom, Dick and Harry cannot go for a coating or something like that. So something, NACE has some qualification, but same type of other industry-based Indian qualifications are required for coating inspector, as we are having a welding related qualification, etc. in other field. As a person, as a user, what I'll be desiring? I'll be desiring the durability of the coating. I'll be going for a ease of application. In case at all, if unwantedly it is damaged, then how it should be quickly repaired? What should be the reliability of that? Wear, erosion, cavitation, resistance, and all those things. What's going to be the long-term performance? Suppose it is meant for some insulation, whether insulation value is going to sustain in a long term or not. What's going to be the efficiency of that? And above all, what is the cost effectiveness? If it is prohibitively costly, possibly people will be a little hesitant to go for that. So such type of things that industry needs to debate and work it out. While there is an immense potential of the coatings almost in every arena of the oil and gas and power industry, but at the same time, these are the parameters, these are the desired, and these are the wish list, you can say, that the industry wants, and definitely the paint manufacturer, coating manufacturers, applicators, all required to be sensitive about that. There are so many emerging trends like self-healing coating. We talked a lot about that. So far, we have not utilized anti-fouling coating, anti-microbial coatings. Partly we have utilized super hydrophobic, oleophobic coatings, like water resistant and oil resistant. We are using it. Biologically active coating to some extent is okay. We are using it. Self-cleaning coating, like you have a coating like on the solar panel or something like that. Photoactive coating, thermochromic coating, and electrochromic coating, and sensory coating, which is a coating itself work as a sensor for giving input to the some other field devices or to other server or something like that for data collection purpose. Coating industry has a vast potential. More someone say about 4.75 CAGR in almost every area of coating, like a metal coating, like a polymer coating, like a ceramic coating, everywhere has a huge potential. With this, I come to end of that. This indicates a huge market, say about 148 billion market by 2027. Somewhere it indicates that more than 5.7 CAGR, compounded annual growth rate, are expected in the field of coating and all those things. So this is something a developing and growing industry, and we need a lot of research in this particular area. Under the Make in India initiative, some manufacturers have come for some of the coatings manufacturers in country, and of course, lot of established manufacturers are also there in India. But these are the items which require a continuous innovation. With this, I end. Thank you very much. Thanks a lot.
Thank you, Mr. Tiwari, for your wonderful presentation and enlightening us on the protective coating systems for the oil, gas, and power industry, and giving your perspective from the years of experience you have had. Would request to unshare the presentation so that we can move to the next speaker.
Sure. Why is it becoming little difficult to?
Just you can close this and unshare it.
I'm not getting unshare button in the.
You're sharing the screen, so you can close the share.
Yeah, that's true. But like, I'm not getting that button of unsharing.
It is in the bottom, sir. Near chat, there is a share screen. Not in a presentation, in the end, Zoom screen, sir. Zoom screen. In the Zoom screen, where it is participant, chat, share screen. You have to.
Yes.
Yeah. Stop share.
Yeah. Thank you.
Sir. Thank you.
Thanks, sir.
So with this, we move over to the next speaker. We have Mr. Sachin Joshi, CEO, Greeno VOC Specialty Coatings Private Limited. Mr. Sachin Joshi is an engineering graduate in polymer science and technology, who carries more than 15 years of experience in development and manufacturing of polymeric-based specialty surface coating for high-end engineering application. So with this, I would like to invite Mr. Sachin Joshi to make his address. Again, he has been part of the Chemtech series of event in the past, where he was a keynote speaker for Chemtech Hyderabad, our flagship event. Welcome, Mr. Joshi, for your address.
Good afternoon. Thank you for the introduction, and I take this opportunity to thank the organizers to giving us opportunity to share the knowledge, exchange the thoughts on the coatings now for various applications, and congratulations for holding this beautiful conference. So yes, my name is Sachin Joshi. I'm a CEO of Greeno Specialty Coating.
And today I'm going to speak about environment-friendly green protective coatings. Of course, oil and gas is a major sector, but along with oil and gas, this has applications in various industries, and various industries going to get benefited out of this development. So in the industry, we use okay, in industry we use different type of substrates. We use metal, we use concrete, we use wood, and we use plastics. And every substrate undergoes the deterioration because of environmental abuses. Like metal, when they get deteriorate in the form of corrosion. So many stalwarts already spoke about the corrosion of metals, the effects, and its a cost. Similarly, concrete undergoes erosion, and we have leakages because the entire structures, we have industrial structures made up of the concrete buildings, and then they undergo the leakages and various deteriorations. So wood, of course, because of UV and water, they get damaged. Plastic also get damaged because of UV. So every substrate undergoes deterioration, and then there's a very well need to protect the surfaces from environmental abuses and enhance the life so that losses can be reduced. So there are various ways to enhance the life of protected surfaces. The most easy, most convenient, and most economical today is by ways of using the coatings. So coating plays a very, very major role in prevention of deterioration of various substrates, not only metal, but almost different type of substrates to enhance the life and protect this, operations or reduce the loss of operation because of deteriorations. Now, when we say the coatings are not used as a protective, this coating should have minimum properties. Then only it will have a really desired effects. One important property is like it should have a resistance to moisture. Now, everybody knows the moisture is a very detrimental, parameter. Because of moisture, metal corrodes. Because of moisture, concrete leaks. Wood gets damaged, plastic gets deteriorated. So resistance to moisture is very important and first and foremost property the coating should have. Second, of course, ultraviolet radiation resistance, because these UV radiations attack the chemical bonds, covalent bonds in the resins and polymers. And then the first is the paint chalks, the color shade change, loss of gloss, and eventually the loss of strength in polymer film, and then deterioration starts. So UV resistance is very, very important, the property of the coating. Third, we should have very good chemical resistance, because along with oil and gas industry, there are various industries, the chemical, they are exposed to chemical atmosphere like acid fumes, alkali fumes, ammonia, chlorine. So the resistance to chemical is very important. This chemical should not attack the polymer film and should deteriorate. Then there is a basically called is aging and weathering. Like there are various changes happens in the environment. There is a change in temperature, change in humidity, then rains, and in various countries there's snow. So a lot of changes happens, and the polymer film should not get affected by the changes called aging and weathering is very, very important. Third is resistance to scratch and abrasion, because after coating, we suppose, for example, we coat and then we load, we unload, we erect. During maintenance, we use a lot of tools and tackles. We work on the surfaces. So the film should be very good, abrasion resistance property, so that it should not get scratched and protect the surface from longer time. Then yes, today this is a very important property of resistance to fire. Normally, in case of fire, the paint becomes a main ingredient which catches the fire and spreads the fire very fast. And controlling such fires is very, very difficult. So resistance to fire is a very, very important property now the customer is looking for in the industry. And last is the high temperature performances. Various applications we need high temperatures, and that the stability of this coating at high temperature is very, very important. So if you really want to develop a coating or have to have a coating or select a coating to protect the substrate, minimum 7 properties are essential, and then only this coating can be a complete solution to your enhancement of the performance. So, but the current demand is not this. Current demand is beyond the protection, and it is called a sustainable green coating. So what is sustainable green coatings? As per the experts and as per the requirements, of course, India is moving towards it, but of course in developed countries, in European and US country, already it has been, the ball has started rolling, because then the coating should address the 3 important parameters. One is environmental concerns, economic concerns, and social concerns. So, but the sustainability is really become a buzzword. Now everybody talking about sustainability. Let's understand what exactly sustainability means as far as coatings are concerned. So in coating, sustainability encompasses four aspects. Now, first requirement of sustainable coating, it should have a low VOC, right? Non-hazardous. The emissions or maybe the evaporants coming out of system should be safe for human, for the environment. So it's a low VOC or no VOC requirement. Second is enhanced performance. See, performance is by default. If performance not there, it is not called a performance productive coatings. So performance by default, but sustainability says the performance should be more than the normal performance given by the conventional coating. So the repeatability of coatings can be reduced. So enhanced performance is the second aspect. Third aspect is a enhanced functionality. Along with this low VOC and enhanced performance, it should add some value. It should have some functionality to the coating so that it have a great effect on the industry, on the end user, and on the society as a whole. So some functionality has to be there in the coating so that it can fit into sustainability. And the last and most important is the cost effectiveness. Because unless it is cost effective, people won't be able to implement it. And then there is no use of this development. So it should be cost effective so that it can be implemented all across, and the benefits of the development can be gained by across the sector, across the industry. So this is basically what sustainable coating. I mean, if all these four factors are there, then any coating can fulfill into the sustainability coating. Now, industry, we use different kind of coatings. We use epoxy coating, we use polyurethane coatings, acrylic coatings, enamel coatings, and powder coating. Essentially, enamel coating and powder coating are for C1C2 applications where corrosion is not, protection is not, or performance protection is not of great importance. While epoxy coatings and PU coatings are essentially used for protection, or they are expected to give a better performance as far as the enhancement of life is concerned. But these coatings, unfortunately, doesn't fit into the sustainability. Because first thing, they are solvent-based system, so they emit a lot of hazardous fumes. So they use a lot of solvents like hydrocarbons and esters and ketones. So they really they go into atmosphere, react with nitrogen oxide, and ozone layer depletion happens. So it's a basically solvent-based system, so they don't fit into the sustainability. Secondly, by way of this chemistry, they are basically homopolymers. Epoxies and polyurethane, they're homopolymers, and it is not possible for homopolymer to satisfy all the 7 properties we have discussed. So what happens to achieve the performance? They need to take a help of various components. So consultant designs a different component system that need a primer, essentially for adhesion and for the basic corrosion protection. The intermediate coat called barrier coat, because the impermeability to moisture is very, very important, and that is why what is called MIO. MIO is essentially used as a barrier coat, so that by the structure of that MIO, the moisture takes a longer route, and then it takes a lot of time to reach to the metal. So barrier coat is important. Middle coat is for basic performance, and top coat to prevent the systems from the attack of ultraviolet radiations. So unless until all these 4 components are being used, we cannot achieve the desired performance. But these 4 coats emits that much 4 times solvents into atmosphere, and it doesn't fit into the sustainable coating. Third thing, because of long curing time, it delays the completion of process operation, and it's prolonged the delivery time. In case of manufacturing, people use ovens to bake the component, and here energy consumption is huge, and then sustainability, again, you are violating. So again, doesn't fit into sustainability. And last and most important is, entire performance of the conventional system depends on the human skill, because that 2-pack system, resin and hardener, you have to mix it properly, weigh it properly, stir it properly, observe the pot life, then observe the basically procedures. 1 coat of primer, wait for 8 hours or maybe 10 hours, whatever thing. So you have to, and then because of the shutdowns are always, you're in hurry, painting is last, and then you take shortcuts, and there's a lot of problem, and then we blame the paints and coating, which is not working. But because of what happens, because the applications are complicated, more human skill, more human error, and more failures. So these are the constraints of the system. So specialty coating is basically a R&D based company promoted by the technocrats in the field of polymer science, doctorates, PhDs in polymer science from UDCT, and we have an industry experience of more than 20 years. And then we have taken this challenge to really give a solution to industry where perfect balance between the green coatings and high performance. So we have decided to formulate a system. Now, the paint system essentially form with the 4 components. One is solvents, which what it does solvent basically gives a workability. So during manufacturing of polymer and during the application of coating, solvents are important. Secondly, additives and fillers, they give some value addition. Pigments gives the color. And the last and most important component in the entire paint system is the resin or polymer, because the properties of the resin polymer is directly proportional to the performance of coating in the field. So what type of resin polymer you select or you develop or you use determines its performance in the field. So it is very, very important parameter. So when we design a sustainable coating, we have to work on the 3 main pillars. One, the solvents. The solvent has to be basically non-hazardous and it should be VOC free. First requirement. Pigment should be ROHS compliant, free from lead, cobalt, and chrome. And the resin should have clean and free from hazardous chemistry, high performance properties, and minimum wastage. So we have to really design a system which can really fit into sustainability. And there we have taken the inputs to how to develop this polymer molecule. The first thing for requirement for the first input we have taken that the basic polymer molecule should be environmental friendly and should have a 0 VOC properties. Secondly, we should have a high performance property which we discussed. All the 7 properties has to be there. Then only it can fit into the performance coating. And third input we have taken that the success of coating should not depend on the application. And it many times it happens, when coating fails, the applicator says there's something wrong in the material, and the manufacturer says, oh, we are big company, we cannot be wrong. So it is something wrong with the application, and the user suffers. So we have taken a challenge and we said, okay, the coating which we developed, it should not be any sort of clashes between the manufacturer and applicator. So performance should be independent of the human skill. And with this thing, we have developed a molecule which we call it as a grafted copolymer technology. Here, unlike epoxies and PUs and acrylates, they are homopolymer. That homopolymer means polymer formed by single repeating unit, right? So that polymer have a properties of that particular monomer. So here we have synergize the properties of multiple monomers, and synergize the properties of multiple monomers. So the entire spectrum of high performance properties included, and it is synthesized with a 2-stage process, because synthesis is our own development, and we got a patent for the synthesis of this molecule. So the synthesis is very, very important, so that we get a grafting. What is grafting? Means arrangement of polymer chains. We have the A is backbone and B is linked to this backbone, C is linked to the backbone, and by which we create the sort of branch structure. So the concept is we take a single thread, you can break it. You make a net of thread, you cannot break it. You need more energy to break it. Similarly, all these 4-5 polymer chains are arranged in a branch manner. So you need a more mechanical, chemical, thermal energy to really break the polymer molecule. So this is basically gives a very high performance properties, and entire polymer is synthesized in a water. So it's 100% water. There is no coalescing agent. There is no solvent. It's a pure water-based synthesis been created, and for this, the technology is called water-based grafted copolymer technology. So this, I won't go into details of the chemistry and how it done. Anybody interested, I can now give this details also. So what are the green features? The first circle of sustainability is what? You should have a low VOC. So since we are using pure water, what comes out of the system is only water vapors, and it is absolutely 0 VOC. So this system is not a low VOC, it is 0 VOC, and we got a lot of test certificates from international laboratories. There is no smell. So even if you take in a confined area, you coat it, it is like water. You won't feel anything. So unlike all the epoxies and PU solvent-based coating, in confined areas, it gets so suffocation. You cannot stand that, and it's not good for health. So this, in this case, absolutely 0 smell, no hazard emissions, save for human who is painting this 8 hours of shift. He's been painting, he's inhaled sort of solvent fumes, but in this case, he will inhale only the water vapor. So safe for him, is environment friendly, absolutely green technology. The first circle of sustainability, it has been achieved. Second circle is enhanced performance. Now, because of grafted copolymer technology, we almost have all the properties. Excellent water cleansing and lowest water vapor permeability. Just 5 grams per square meter in 24 hours, where all other systems are 29 grams per square meter per 24 hours. So this is a very, very important property, that water vapor will not permeate through or penetrate to the polymer film. And that is the reason it's successfully behaved, because moisture is the key component which will deteriorate the surface, whether it is metal or concrete or wood or plastics. So it has a very excellent water repellency and very low water vapor penetration. Secondly, UV radiations is very, very high. No effect of sunlight, no change in performance, no change in color, nothing will happen to this. So very good for outdoor applications. It's very tough and abrasion resistance. After coating, you can use it, you can walk it. I've seen people know in Mumbai we have a lot of problems with the space, people playing cricket in industry on checker plates, trolleys are moving around. So it's very, very tough and abrasion resistance, because it has that the grafting gives a very high strength for the puncture resistance or tear resistance. External flexibility, yes, because of expand contraction, as temperature increases, substrate expands, temperature reduces, substrate contract. And this expand contraction is not a one-time process. It's 24/7, 365 days. So it shouldn't happen first 3 months it is going good, and for 6 months it's reducing. So this technology gives a 10 years, 15 years retention of properties against all the environmental abuses, and very high resistance to chemicals and corrosive gases. So performance properties, second circle, enhanced performance, we have achieved. Now the third circle is what we have taken objective of the performance should not depend on the human scale one, and then cost effectiveness. It should be very, very cost effective. To address that, we have got excellent features. One, it is single pack system, ready to use. Nothing to make. There is no paint kitchen to be done on the site. There is no need of different stirrers and different weighing machines on the side. There is no human skill required to prepare the paint. You open the tin and start applying it. So the human error of preparation of the paint on the site is zero. So chances of failure are absolutely nil. So this is a very, very important property, that there is no need of any mixing, solventless system, not even water to be added into this. Moment you add something, water or solvent, it will get spoiled. So nobody can play with the quality of this system. Second, pot life. Now pot life is a big, big problem in the industry, because once you mix A and B, and if you don't use it in specific time, it's a waste. First is a law, basically loss, monetary loss. But second important is that disposal of that hard material, because disposing of this thing it is a burden on your earth, and disposal of this hard material is very, very difficult. In this case, if you open the tin and if you consume half the quantity, you again close it. Even after 6 months, you can use it, because there is no pot life applicable at all. Third thing, it dries within 30 minutes. It's a very, very fast drying process. So what happens when a normal system, now if you take 3 days to complete the job, this system you can complete the job in half a day. So 2.5 days of time and 2.5 days time or 2.5 days of labor are saved, and both are very important. You just imagine the shutdown time. When a shutdown time is a cost, when you stop the production for 3 days, the loss of production is huge. It goes in millions of dollars. And if you can reduce the shutdown time from 3 days to half a day, you can save millions of dollars. And that is a huge saving cost. And then labor cost, of course, labor is today very expensive. So saving in labor also is very, very important. So all put together, it saves a lot of cost. Secondly, application, it doesn't require any specific pumps or heating systems or nozzles from Germany or USA. No, conventional brush, roller, gravity cup spray, airless spray, you can apply this absolutely with no problem. And you can apply in all substrates. You can apply ferrous, carbon steel, mild steel, non-ferrous, aluminum, copper, even on galvanized steel directly you can apply this coating without primer. On concrete, on wood and plastic. So what happens, because of the grafted copolymer technology, you add the value, you increase the quality. With on all the efficient features, you reduce the cost of application. So this is called value engineering. You add the value and you reduce the cost of application. So now the last circle. So we have achieved the sustainability with the green features, with functional, with high performance features, cost effectiveness, and last is what is what functions or what value it can add to the industry. So to add the value, we have 4 coatings, which is creating a tremendous value to the industry. So there are 4 products based on this basic polymer chemistry, polymer molecule. One is high performance anti-corrosion coating. Second is complete replacement of hot dip galvanizing with galvanizing coating. Third is thermal barrier coating with under insulation corrosion protection. And last is heat insulation energy saving coating. So quickly I go through which, and then we can have question and answer session. So yeah, so anti-corrosion high performance coating, as I said, we have tested for various properties, 6 properties, and very interestingly, it is tested at just 100 micron thickness. Now thickness is a parameter of system, is not a parameter of performance, because considered as suggested 4 coats with primer, middle coat, top coat, automatic thickness goes 300 microns or 400 microns, and somebody skips the 1 coat. By naked eyes you cannot measure it, so always it has been measured thickness. So it becomes a parameter of system. Now if thickness is a parameter of performance, then you can take a wax and put a 4 mm wax. Will it perform? No, because wax doesn't have properties to perform as a protective coating. So what is important is the properties of the polymer coating going on the surface. And since this coating, this polymer molecule has a very high performance properties, thickness is not important in case. So we have tested all the properties on just 100 microns of dry film thickness. So 1000 hours sales facility, absolutely no corrosion, tested at all enable accredited labs, even international laboratories in Dubai and UK. 1000 hours of UV at 3 and 13 nanometer lamp, no chalking, no color fade, no change in properties, very high resistance to chemicals like sulfuric acid, hydrochloric acid, nitric acid. Now 33% nitric acid, if you dip the normal plate in 33% nitric acid, in 8 hours it gets dissolved. And this has an excellent resistance to nitric acid, boiling caustic, all gases, CS2, H2S, absolutely very tough, very high scratch hardness, 3 kg at moving needle. Very good flexibility resistance at 3 mm conical membrane, no crazing, no cracking, so excellent flexibility, very good impact. And most importantly, the service temperature is -40 to 200 degrees centigrade. Up to 200, 250 degrees centigrade, nothing will happen to this, it will remain stable and perform as a protective coating. So there are the test report, we have got from the various laboratories. So what are unique features? There is no hardener, no solvent. So absolutely safe. Easy application, quick drying at room temperature. Absolutely means whatever room temperature, I mean room temperature, even at a C, where the humidity level is almost 85%, 90%, still it will dry fast. Easy touch up and recoating without scrapping is very important, and safe coating because no smell. So you can coat in the confined areas, in the pipeline, in the tanks, in the reactors, in the water tanks, whatever, like it's very safe to coat. So what are the benefits? Yeah, high performance at low DFT, so you save in material. It saves manpower because it's fast drying, you save tremendous on manpower. You save time because it is because of fast drying, you can complete the operation very fast. You save energy because a couple of my customers, they have stopped using ovens and they are selling carbon credits now because no ovens are not required. So save energy. So all in all, what you save is a tremendous amount of cost. So these are the certain projects executed with this technology. We have done 85% today our product is for export. So we are established in Northern Grid, Power Grid, and United Kingdom. You can see the photo. This photo we have coated this for 3 years back, and adjacent is the normal epoxy coating. You can see the difference after 3 years. Even here, not even gloss has gone. And what are systems? Epoxy system: 100 microns primer, 100 microns MIO, and 100 microns alkyd epoxy. Time to complete transformer coating is 8 days. So 8 days your revenue is stopped. When you change to this, only 2 coats, 100 microns, and within 3 days we are handing over transformer to the power grid. So you can see 5 days of revenue is saved, labor is saved, and there's a lot of cost saving is there with better performance. We have done tank farms and port, Malaysian port. It's a loop biofuel tanks. Coating system was 1 coat of primer, 2 coat of epoxy, and then high downtime, chalking within a year. So you can see we are not removed the coating, early coating. We just cleaned it with this now little sanding and high water pressure jet, 2 coats, and it absolutely it is 3 years is as it is. We have done Indian Oil Corporation, Bombay. We have done a tank farm top coating. We have done with this coating only 2 coats, 100 micron. Still, it is going strongly. Metal Toyota, Switzerland-based company. All the metal, all this weighing scales, structures are being coated with this thing. Earlier, it was 1 coat primer, 2 coat epoxy. Drying time was 4 hours each coat, time to pack 24 hours. So the entire factory used to fill with the big structures. After that, only 2 coats of this coating, time to pack is 2 hours. So productivity increased by almost 300%. We are replacing powder coating. This we are done with Reliance in Jamnagar and Nagotne plant. Entire control panel has been coated with this thickening. There's no 7-tank process, there is no oven, there is no extrusive gun, simple compressor, just 30 minutes drying, 80 micron thickness and done. Walls we have done, and then we have got a fire retardant coatings. It will have a very high fire resistance, straight resistance. So FSI, fire spread index is 5, where people say it should be less than 25. Smoke development is 0. When you take the fire on the coated panel, there will not be any smoke, 0 smoke. So it is fire class 1A. So this is anti-corrosion. Secondly, quickly, is a replacement of hot dip galvanizing. Now, hot dip galvanizing is a very hazardous process. You have to dip the coated, you dip the structures into the molten zinc with high temperature, with tin and nickel, toxic fumes, not good for environment, not good for human. So we have developed a coating which is replaces the hot dip galvanizing with superior performance. It is tested at Exova, Singapore for ASTM 123A2. All properties are tested as per galvanizing properties. It is 30% better than hot dip galvanizing. Advantage on-site and off-site. You cannot do hot dip galvanizing on-site. Something goes wrong, you use sprays, and that sprays is eye wash. Here you can do 1 coat in factory, 2nd coat on the site, and you can protect the surface, easy touch-up, and cost saving up to 40%. So these are laboratory tests. With hot dip galvanizing, you can do white rust. You can see the white rust. Where coated, we have done a scratch, and you can see there is no spread of corrosion beyond the scratch, called creep resistance. Excellent creep resistance of this coating. So we have done Reliance from the Dahano to Borivali. We have done all this towers already coating. Now it's 4 years now. Even today you go, not even gloss has gone. For Marshall, we have done entire factory.
So Sachin, we just exceeding a little bit time.
Oh, it's done, huh?
Yeah.
Okay, fine. So I will skip other products and I'll go to last. So this is then we have got a thermal barrier coating which can reduce the insulation. Under insulation corrosion also can prevent. You can reduce the insulation thickness. So these are the widgeted. So okay, I'll go fast. I will reach last thing now. So these are the things we have done. We have done Indian Railway heat insulation coating and cars and everything. We have to tank farms in this thing. So there are the sectors we are doing. So yes, what we achieved sustainable coatings. It is effective and long-lasting performance, enhances safety because of water-based. You can store, you can transport, no license are required for storage. It controls losses because there's no pot life, reduces cost of coating, recoating, maintenance inspection, it saves a lot of energy, it ROHS compliant. So sustainability completely achieved. We have taken care of environment, it takes care of society, it takes care of economy. So let's add joints to create a green, safe and reliable working environment. Thank you.
Thank you. Thank you, Mr. Sachin. Thank you for your wonderful presentation. You can unshare your screen and so that we can move to the next speaker.
Sure.
Now we have Mr. Mahesh Kumar Aradhya, who is the Associate Vice President R&D of Grover & Well India Limited, an MBA and surface coating technology and an NAC certified protective coating specialist with more than 26 years experience in the wide field of surface coating technology. His lecture title is Challenges for Under Insulation Surfaces and Recommended Paint System. So with this, I would now like to invite Mr. Mahesh Aradhya to make his presentation.
Thank you very much, Sudhashiji. And I'm trying to make play presentation, but unfortunately it is not getting played actually.
It is, I can see it. We can see it on the screen.
You can see the presentation onto the screen, but I'm not able to focus the screen.
Can you come again?
I'm not able to show the only screen. I'm able to
see. You can in the right hand corner, There is a button called this where you can show the full screen. Right hand corner next to the bar where you are minus plus 65%. Next to the screen, this is a full screen.
Oh yeah.
Not there. Go left where minus is written. Next to the minus, there is a full screen button.
Yeah, but I'm trying to do that.
No.
This one.
Immediately after.
Yeah. Now. So you can start a presentation.
Yeah. Very good evening to all. My name is Mahesh Kumar Aradhe. I am Associate Vice President, Graur and Weil India Limited. Okay, I'm basically a NES International CIP and TCS instructor. So I will be giving reference mostly to the NES Internationals as far as the standards and the working conditions are concerned. I'm going to talk about the high heat resistance coatings, for CUI, corrosion under insulation. What were the coatings that available at this time in the market are either heat resistant or CUI coatings. The heat resistant coatings can be in various different forms. Okay, they can be either of modified phenolics, they could be of epoxies, they could be of phenolic epoxies. Okay, and they are having a certain property which may give you or which may not give you the durability. For example, if you take epoxy, it can have a temperature resistance, okay, 200 degrees C up to, I'm saying. And these temperatures, what we see here, 200, 230, 250, 400, 600, these are the dry temperature resistance. And that too for, it is a continuous range of the temperature. It cannot be a cyclic temperature at all. When it is a temperature which is in the fixed range for the longer time span, yes, definitely they work as per the requirements given in the specification. But what happens? The systems which are above 120 degrees C, when we see the areas like atmospheric zone, uninsulated services, they perform very well. Steel onto the stainless steel, onto the various requirements. EFT requirements in those systems could be from 25 microns to 100 microns. Now, these coating works to give you certain properties, but it is these things may not be used to protect the insulation or insulated pipelines or insulated any type of equipment. Then why we are talking about the heat resistance about and the anti-corrosion resistance about 200 degrees C? New construction, yes, they are using inorganic zinc silicate as a primer. It is very much suitable to be used as a for the uninsulated area. When it is an uninsulated area, the performance expected from the system like zinc silicate primer is very, very high. Then why you need to overcoat the inorganic zinc silicate? Because first of all, when you use inorganic zinc silicate as a primer, it is a mortar-like structure. It has got pinholes. It has got the voids. These voids may hold some of the moisture which is coming from the atmospheric condition. Now, if this moisture interacts with the system, then it is possible that the areas nearby may have some salinity. And this salinity can disturb the whole corrosion process. It may be a very high concentration of electrolyte near the voids, which may completely destruct if the temperature is high and the line is getting colder because of the condensation that happens onto the surface while it is getting colder. So when it is happening, when you apply it, we go with the issue like corrosion under insulation. So what is there which makes that particular insulation area, that is a under insulation area, very, very sensitive to the temperature, as well as it is a continuous one, absolutely no problem. But when it is a thermal shock, it is very severe. What happens here? You can see the insulated pipeline here in the picture. You can see the insulation is made with a rock wool. Now, if this rock wool is used, or say sponge, or the polyurethane foam, or any other type of insulation is used, it has a capacity, moisture absorbed in it. Now, once the pipeline is heated, it becomes dry. Once the pipeline goes back down to the temperature, condensation starts. With condensation, all the moisture sits in the insulated pipeline. This moisture goes down to the surface. This moisture is also carrying the salts with it. So I can directly say that instead of a condensation, it's an electrolyte which is going to go down. Now, in such situations, it could be a chlorine gas, it could be a sulfur, it is going to be dissolved into it. This dissolution is going to create an acidic media or an acidic electrolyte, which when heated at that particular temperature, it is going to make a situation very, very critical, because the acid, high temperature, both are going to react with the surface below it. Okay, the concentration of electrolyte is very high. So once this is close to the surface, the pitting or corrosion starts. So it is very, very vulnerable. So what is the issue? I want to remind you a NES specification, that is NES SP 108. This is the specification which is derived for the coatings for under insulation and under no insulation areas to be used onto the offshore structure. As far as NES is concerned, they haven't given any material recommendation in any of the specification, but specifically in NES SP 108, they have mentioned it that for the insulated area, you must go for the only TSA, that is a thermally spray aluminum zinc, to be used under insulation areas. Then why coatings fails in those areas? The under insulation area, why they fell? Let's understand from the mechanism. The insulation is just water, okay? Water vapors condensation is the water which is getting trapped inside at temperature. The temperature gradient is very, very high. Thermal cycling is going on, and that's the reason the inert material is needed inside. So what can be an inert material inside the insulation is you have to use either coupling compounds such as aluminum or zinc. Now, this has given a grand success as far as CUI is concerned way back in 1997 with British Petroleum. Then we had very limited knowledge that time about the corrosion which is going to take place under insulation. So they thought that we should go with a thin layer of high temperature resistant coatings, then the shock primer, sacrificial zinc happened. But what happened? The operations which are having a thermal cycles, we call it as a thermal shocks, or you can also call it as a temperature cycles. Most of the material have shown failure, such as zinc silicate, such as organic coatings, such as silicone coatings. And how? Let us see. The oxygen is there, temperature is there, chemical source are also there, humidity is there, and pollutants and acid gases were supporting the corrosion under insulation. Here, the temperature is also high. As the insulation is wicking the surface, it is also wicking the oxygen to it. Humidity, it is taking in the consideration to reach or make the acid products such as hydrochloric acid or sulfuric acid by mixing it with various gases. Okay, humidity is also very high there, and when you have a thermal shock, the condensation is also taking place. All these are making that particular electrolyte under insulation very, very high concentration, very, very high temperature. And so the reaction is also very, very fast. So what you need here, as I have explained in the picture, what you need here, you need a coating which can sustain the temperature as well as it can move along with the surface. Have that much tensile, that much flexibility. Ensure the compression and contraction of the pipeline. Now, when this is going to happen, what you need here is we must not use hard coatings, okay, such as zinc, organic zinc coatings. You can't use even the surface which is having a galvanized surface. Equipment of a material which is galvanized, no way. So it is not going to give you that kind of a under insulation properties. Why it happens? It gives that particular service under the cyclic services, which can deteriorate the quality of that particular structure. It can go under corrosion issues very, very fast. So the second thing which was there are the challenges. Major problem is the existing situation. Need for the wide temperature range. It may be operated at minus 260 degrees. It may be operated at plus 650 degrees C. Need to have a material when you are using it in the in maintenance and repair. It was looking out for the what do you call it, as a hand tool or cord preparation, such as S2, okay. Often hydrolytic is also not possible. They'll say that go for the hydrolytic. In the industry like oil and gas, it is just not possible. Shut down, absolutely not possible. They were requiring the application to the hot surfaces. Now again, this is a big safety issue. So we took this challenge at Power and While India Limited, and we made a solution as Pentatherm 750. So what we did here, we started with very different types of polymers mixing together, as Mr. SK, as Mr. Sachin said, that how we have made the grafted polymer. Yes, we also made a grafted polymer, and we started working with NES SP018 2010. We tested this polymer up to the 650 degrees C range. We tested this material at 90 degrees C saline solution conditions for 4,000 hours. Okay, we have tested for acid and hydrocarbon resistance, and we kept our VOC level below 263 63 grams per liter. Now, when we made this particular polymer, we chose the other ingredients such as the pigmentation, the use of different types of extender, and some special additives to give a proper adhesion at high temperature also. We had also ensured that this particular material will have a higher or unlimited overcoating time. So what we did here is, as per the market references, there were two companies who were giving this type of a material. One is single pack, other one is a two component. We have made the standards of application very easy, okay, up to the temperature of more than 650 and peak temperature of 750 degrees C. That's why it is called as 750 pentatherm 750 COI. And it has the temperature of more than minus 185 to 550 degrees C. But yes,
you can have another 3-4 minutes. So
oh yeah, why not 3 minutes? No problem. So we applied those panels as a inert matrix coating onto the various substrate, and we also carried out shell CUI test. Okay. When we have done it, we found that there are absolutely no defects into the film as far as the exposure is concerned. Exposure was 16 hours at 204 degrees centigrade max, thermal shocks at 23 degrees centigrade, and then again a hot water immersion at 95 degrees C. It was the repeat cycle of more than 80 cycles. We have tested our pentatherm CUI and found to give maximum resistance to all the CUI tests as per the shell specification. Corrosion resistance, what we found was max 1 mm creep. Delamination, which was observed in other coatings, was such. It was very high. Then we also tried to give the hot water resistance at 4,000 hours at 95 degrees C. We almost replaced our water, refilled our water more than 600, okay, because it was going all out of the system. I don't believe this particular test, because most of the time it was showing that there is a delamination taking place in both the competitors, because there were the blisters which were occurring. So I retested it once again, a separate manner, and the results were absolutely same. Then we tested it for the various chemicals, such as 10% hydrochloric acid, 10% sulfuric acid. We found that it is giving us both the hydrocarbon as well as temperature resistance, acid resistance with that particular area. Absolutely no issues. Then there were few normal tests which is normally carried out at site. We followed out and found that it is meeting a very high impact resistance as well as adhesion as well as hardness. The pencil hardness we found to have more in terms of intercom COI. Now I want to show you one video as such, which is going to give you a clear idea. At 121 degrees centigrade, we have kept a corroded panel without doing any kind of a surface treatment other than ST2, ST3. Then we took out, you can see the safety precautions that we had taken. And at that hot temperature, I took a chance without any PPEs to apply the coating onto the hot surface. This COI, you can apply it onto the temperatures up to the temperatures of 100 microns, 100 degrees C easily. Right? You can see some fumes there, but these are not poisonous material. It is the smell of those solvent which are very slow evaporating. Very, very slow evaporating. And all the tests were performed, and what we found that if the blast turning is possible, service temperature up to the with our CUF, that is phenolic landings, is possible, and services above this we have to go only and only with the systems which are going to give you a higher degree of corrosion resistance. Thank you all for your.
Thank you, Mr. Mahesh. Thank you for your wonderful presentation and the video, which was really there are people from NTPC also, and Indian Oil and ONGC and GAIL who are right now watching as a delegate, and it was really enlightening. Thank you once again.
Thank you very much. Thank you very much.
Can you unshare your screen?
Is there any questions? So
The question we will take in the end, this after all the speakers are presented.
Okay.
Yeah. You can unshare your screen, sir.
Yeah.
Now we have Mr. Merrick Alpert from Ion Coat LLC, presenting out of Farina, North Carolina, USA. He has joined us. First of all, welcome. This is a very odd hour for you. It's a very morning time, all the way from North Carolina, USA. Lecture category, developments in anti-corrosion coatings, and the lecture title, a permanent way to prevent corrosion on carbon steel. Ion Coat's Mr. Merrick Alpert will share publicly how Chevron, BHP, Total, Nexen, Sinopec, and other multinational oil and gas companies have been successfully using the patented Ion Coat and anti-corrosive coatings. And thanks you once again for joining us all the way from US. Very good morning to you, and it is good evening at our end. Over to you, Mr. Merrick, for your address.
Thank you so much. Good evening. I'm actually in the state of California today, so it's even a little earlier here.
Yes.
This is, you have helped me get up for breakfast this morning, so thank you.
Okay.
I want to begin by thanking again Mr. Pandey of ONGC, Mr. Nagar, and the Chemtech organizers. This was very important for me to join you this morning, even at 4:30 in the morning in California. And the reason, at the most basic level, is that I've been to India twice, and the ability to work with the various groups in India is very, very important to us as a company and very important to me as a person. And so thank you for having me. What I'll do is I'll come in and share my screen, and then we'll go through the presentation. And let's see. Please let me know if you can see the screen now. Are you able to see that presentation?
Yes.
Okay, perfect, perfect. I'll minimize this. And we'll begin. Excellent. Again, thank you. Jumping right into it, the name of the company and the name of the coating that I'm going to present on, the anti-corrosive coating, is the same. It's Eoncoat. Okay. What Eoncoat is, in a sentence, is a method of preventing corrosion on carbon steel. It is not a paint. And so I'm going to take you through how it is different than a paint, how it delivers superior results to a paint, and then I'll show you its actual use in the world. To begin with, what Eoncoat is a plural component system. You have an acid component and a base component. Those are both going to look like white paint when they're in the can. The acid component has roughly the same pH level as a glass of orange juice would, so it's not a very strong acid. The base component has roughly the same pH as an antacid tablet, so again, not a very strong base. But when you bring the A and the B together and you use them in a plural component pump and spray them onto the steel, you of course have an acid-base reaction, and that creates the chemically bonded phosphate ceramic that is Eoncoat. Eoncoat comes in two basic formats. The gentleman that just spoke gave a great presentation on CUI and all the dangers and problems of corrosion under insulation. Eoncoat comes in a basic atmospheric form. So you can use the Eoncoat on above ground tanks, above ground pipeline that's not insulated, on offshore platforms. So that's what we consider the atmospheric use of the coating. When it's used in that format, we always use a top coat over it. On the other hand, we have a high temperature formula. It's often used in two scenarios. The first is corrosion under insulation. And the second is that it is used as a weldable material. When it's used for corrosion under insulation or used on the bottom side, the soil facing side of a tank, for example, that's going to be welded on the opposite side, in those cases, no top coat is used. It's a single coat system. Only the Eoncoat is used. So again, for purposes of this evening's presentation, we have Eoncoat in the atmospheric form and then Eoncoat at a high temperature form used in the corrosion under insulation environment and also used in the weldable environment, most often on the bottom soil facing side of tanks. So a little more detail on how this works. As you have the bucket of A and the bucket of B, they go through the plural component pump and get sprayed onto the steel. The first thing that happens is that you actually have two mechanisms for corrosion protection. The acid component goes into solution, it touches the steel, and it draws the Fe, it draws the iron off the surface of the steel. That is what's going to form the passivation layer. That's the most important thing that's taking place when you spray the Eoncoat onto steel. And then second, what you're going to see as you're spraying it is the formation of that acid-base ceramic layer. Again, this is all going to look like you're spraying white paint. But if you slow down the reaction and think about what's happening, you are actually passivating the steel and you're forming an outer ceramic layer over the passivation layer. So again, Eoncoat is not a paint. It is a method for passivating carbon steel. The most important slide that I'm going to show you this evening is this slide right here. And I'm going to actually use the little laser pointer to show you it. This is a scanning electron microscope photograph taken at 6,500 times magnification. This is an Eoncoat that has been sprayed onto carbon steel and then it's dried for a few minutes. So first you see the carbon steel at the bottom. You can see that typical grain pattern of carbon steel if you're familiar with the way the carbon steel will look under the microscope. Second, you see the dry Eoncoat up here. You see the typical indications of a ceramic that you'll see an acid-base ceramic out here. Most importantly, look at this dark area. where the Eon coat has touched the steel when it was wet and then dried. That dark area right there is the passivation layer. That is the area that prevents the oxygen and moisture from touching the surface of the steel. Now, that area is only about 2 microns thick at any point, but it is that area, it is that passivation layer that prevents the steel from corroding. When I was in India on one of my trips there, I went to go see one of the most important monuments to anti-corrosive technology in the world, probably the most important monument, and that's the Iron Pillar of Delhi. For those of you who are familiar with the Iron Pillar of Delhi, a similar mechanism is used within the steel, and that's why that pillar has lasted for 1,600 years. For those of you who have not gone to see that in India, I would urge you to see it. It's a monument that everyone should go see because it demonstrates how you can get incredibly long corrosion protection on steel. Now, what I want to show you here is the same scanning electron microscope photograph, but in this case, we're annotating it to really emphasize the fact that the reason at the core root of the problem, if you look at the root cause of corrosion, it's occurring because you have a reactive surface. It's occurring because oxygen and moisture can touch that steel and steel will corrode. So what we do with Eon Coat is we go right to the root cause of the problem. We passivate the surface of the steel. It can no longer react with the elements. And because oxygen and moisture can't touch the steel, it will not corrode. This is a different scanning electron microscope photograph. This is in response to people saying, what does it look like at the passivation layer? What does it actually look like right on the surface of the steel that you've chemically altered to prevent oxygen and moisture from touching it? Again, you can see the steel at the bottom. You see up at the top the ceramic, and then through a series of actions, chemical and mechanical, we've actually torn away the ceramic. It took some doing, some time for us to figure out how to do it, but we tore it away. And then look what's revealed, the iron magnesium phosphate layer. That looks like white snow. That is the passivation layer that prevents oxygen and moisture from touching the steel. Paint will never do that because paint is, of course, a barrier coating that's mechanically bonding. But with Eon Coat, it is chemically bonding to the steel. It is passivating it, and that is how it prevents corrosion. Now, what I'll do is take you through some in-use testing for some of the major companies, petrochemical companies in the world, like Chevron, and then I'll show you their actual in-use in the field so you can see how it's actually used. So to begin with, this is, of course, the ASTM B117 salt fog test. You're familiar with that. It goes into a test chamber, the panels do, and then they're sprayed night and day with salt water. It's the typical, the most basic test for anti-corrosive coatings in the world. We start with a new panel, and then we cut the scribe line in it. With Eon Coat, you have to make certain that you cut through both the outer ceramic layer and the passivation layer. How do we know we got all the way to the steel itself? Because at 8,568 hours, about 1 year, you can see what's going on. Now, most importantly, if you look here, what do you not see? Well, you don't see the scribe growth or scribe creep. You don't see underscribe. You don't see the bubbling that you would see with traditional paint. And why is that? Think back to the scanning electron microscope picture you saw. Because you've passivated the steel, you cannot get behind that passivation layer. You can't get behind the alloy layer. And so the long and short of it is, yes, you can mechanically damage it, but it will never grow. You will not see a growth in the area that you've damaged. Now look at this slide. It's like a time-lapse film that you're watching move along. Here at 13,704 hours, it's about 1.5 years, about 18 months. Same thing, no growth of the scribe line because, of course, you've passivated the steel beneath it. We actually used a little light grit sandpaper here to demonstrate that this area out here was just stain, it's not rust. And so we scraped that away so you can see it. Now, the data I'm showing you now, these slides are from Chevron Corporation. I can show you these because Chevron went public with this in 2018 at the Eurocore conference in Krakow, Poland. I was sitting in the audience watching. We were not part of this testing, and we were only shown this after Chevron completed the testing. They were trying to simulate mechanical damage just to see how tough and robust the Eon coating was with a passivation layer. So they started with 3 flat panels. They bent this panel in half. They knew that here where they're exposing the fresh carbon steel, they're going to see corrosion. But they want to see, can you maintain that true edge? Can you maintain that line? Or is it going to peel back the way that paint would? And then you see with hammers and chisels and saws, they've simulated mechanical damage by trying to tear away the ceramic. They then put those panels into the salt fog chamber for 335 hours. To be expected, the fresh steel, of course, where they exposed the fresh carbon steel, it corroded. But most importantly, look what happens here, or look what doesn't happen. Here, you see how it has not peeled back. It hasn't peeled away. And the reason for that, of course, is because you've passivated the steel. Now look at these other areas. If you didn't know it was Eon coat, you'd think to yourself, how's that happening? How could you have carbon steel in salt water for weeks and have it not corrode? But of course, you now know that you're not actually looking at carbon steel. You're looking at that thin passivation layer. So even when that outer ceramic layer has been torn away, you still have the protection of that passivation layer. Chevron then takes those 2 side panels and puts them into salt fog for months, 1,870 hours. Same result. Look at that. You see no corrosion. If that was paint, it would be blistered and bubbled and it would all be gone. There's no corrosion. The only corrosion you see is actually just the rust bleed from the uncoated back of the panel. Now, speaking of CUI, speaking of what works and what doesn't work in CUI, here we see actual field testing on live pipe at Chevron's largest refinery in the United States, a place called Pascagoula in the state of Mississippi on the Gulf of Mexico. Hot, humid, salt spray in the air. This is Chevron's test data. We have not altered or changed this slide in any way. This is the way Chevron presented it at the Eurocore conference. And so if you just look in Chevron's own words, what they do is they spray the coating, they let it cure, they then scrape it off, they then bring the pipe up to temperature and run it for months and months and months. They then take the insulation blanket off and take these photographs. So look at what's happened. Even in a CUI environment, in those brutal conditions, even if you scrape away the outer layer of the coating, the passivation layer still prevents corrosion. Or in Chevron's words, just as written, no rust. Now, what I'll do is show you a couple of photographs as we're finishing up so you can see what it looks like in the real world. This is one of Chevron's tanks. The first thing that should jump out at you is, look at that level of rust on that tank. Look at that flash rust. With Eon Coat, we actually spray it on flash rusted steel, and there's no issue. Because of course, we'll use that flash rust, we'll use that Fe to help create the passivation layer. So notably, that rust on the tank is not our enemy, it's actually our friend, because it's going to help passivate the steel. And then, after it's been spray applied, a top coat goes over it. And if you drove by that tank, well, on the first day, you wouldn't know any difference. But years and years and years later, you would, because of course, this tank will not corrode, but the tanks around it that have regular paint will. This process is the same, whether we're spraying a tank or whether we're spraying a pipeline or an offshore platform. This is one that we did recently for Sinopec in China, for example. Again, the same equipment, the same coating that's being sprayed onto that steel. So here's the wrap up. Here's how we do it. First, it has to be carbon steel. We need reactive steel to form the passivation layer. We have to be able to draw the Fe off the surface. You see this gentleman up on a flash rusted roof of a tank. Then what we're looking for surface preparation is We're looking for a basic commercial blast, much cheaper, much less expensive, much faster than taking it to white metal and trying to hold the blast. People blast the entire tank or pipeline section or section of offshore platform, and then they apply the coating. We apply 20 to 25 mils. That's about 608 to 635 microns. And then for an atmospheric use, like a tank like this, you would use a top coat. But of course, in the COI environment or for the weldable coating, we would not use any top coat. It's a single coat system. Here's what the customers tell us the benefits are in this order. First, there's a significant reduction in the asset being out of service. The blast is much, much faster. And the Eon coat is spray applied. It cures within minutes. And then you can put a top coat on if it's for atmospheric use. Second is the predictability of downtime. Unless it is raining, you can apply the Eon coat. And so when you schedule the work, you can actually do the work. Then there's the initial lower cost of surface preparation because per square meter, it's so much cheaper and faster to go and take it just to a commercial blast and not a white metal blast and not have to worry about the corrosion. Then finally is the elimination of the ongoing cost of downtime and the surface preparation. Chevron estimates they will get at least 40 years out of the coating when it's used in an atmospheric environment. Now, the last slide are the HSE environments, the health, safety, and environmental benefits. These benefits come because the product is water-based. It is inorganic. It's made of minerals and water, rocks and water. That's it. It's not toxic. There are no volatile organic compounds. No volatile organic compounds. Not that you have to say it's low. There are no VOCs. There are no hazardous air pollutants. It is not flammable. You could not burn it if you wanted to because it's just rocks and water. And finally, there is no odor. There are no fumes. There's no vapor, nothing of the sort. It is rocks and water. So the product is in use around the world today, and we would be delighted to be able to work with you to be able to protect your assets, be they onshore or be they offshore, whether they're atmospheric, whether they're CUI, or whether it's a weldable environment like a tank bottom. And with that, I would thank you. I'd be delighted to take any questions that you have. And if you don't wish to ask them now, then by all means, I certainly can answer any of those in a follow-up.
Thank you, Mr. Marek. Thank you for joining us. We will have a question after the last speaker has presented, which is there. There are questions in the chat, which I'll be posting in the chat in the Zoom box. Okay. Thank you for your joining us all the way. A very good breakfast to you. Very good morning to you. And thank you for a wonderful presentation. And it was inspiring and enlightening. So
thank you so much.
Yeah, if you can unshare your presentation, I can move over to the next speaker.
Okay, perfect. Thank you.
Now, I would like to invite our last speaker of the day, Mr. Manoj Akkad from AMI Polymers. His lecture title is Fluoropolymer Coatings for Oil, Gas and Power Sector. He has graduated from IIT Mumbai in Mechanical Engineering in 1970, returned from US in 1975 after getting Masters in Plastic Engineering and experience in Teflon coating and licensed applicator of duopont. So with this, I would like to now invite Mr. Manoj to give his address. Over to you, Mr. Manoj. On mute.
Yeah. Thank you so much. Let me just load my
There's a share screen button in the Zoom.
Yeah.
That you can share.
Are you able to see it now?
No. Can you share the screen?
Yes, I did press on that.
You have to press on share screen button where next to the chat button, this.
Yeah, I did that. Next to the, I have pressed the share screen button. Yes.
And you have to share your presentation. You have not shared your presentation.
This is what the presentation. Can I send it to you and you load it up?
Yeah, you can email it to me.
I just sent it to you.
Yeah, you can share from here. You can click on the presentation at Chemtech. Click on presentation at Chemtech.
Can you see it now?
Should I share it?
Yeah, please, you share.
Yeah. Just I'm sharing the screen.
Okay. Yes, correct.
Yes.
So how do we go up and down this slides?
That you have to tell me next so I can move over. So
Okay.
you can start with the presentation.
Yeah, all right. Let's go to the first slide. Not this one, the earlier one. Yeah. So this is for the, good evening, everybody. This is Manoj Akkad from Ami Polymers. We do Teflon coating on customer equipment, and we are licensed applicators of Chemours, which was earlier DuPont. We started this company in 78, and we became licensee of DuPont in 82. And so you can imagine we've been here for a long time. My partner Vipin and myself, we learned the technology in USA with another licensee of DuPont at that time. And we tried and used the technology for the industry for a long, long time. And so there were lots of challenges. One of them was that in the initial years of this, before the new industries came up, that everybody had collaboration with a foreign company. And so before they made any changes and use any new technology, they had to actually ask their collaborators whether they could introduce the changes, and they could not. So can you next slide? Right now, the industry has many technical executives, and they are strong, they are powerful, and they have the guts to try out new things in their industry that you don't have to ask any collaborators. And so my theme today is really not about what Teflon coating can do and cannot do and its technical aspects, but to say that we should work together with the industry for innovation and improving the functionality of this. The challenges that the industry faces are about regulation and, of course, competition from the renewable energy sources. So I think this is an invitation from us to the industry to let's work together and solve the corrosion problems. Can we go to the next slide? So this is one of those projects where Reliance Industries asked us meaning AMI Polymers and Chemours, who are now the owners of the Teflon brand, whether we could solve a problem in their crude overhead piping for conveying naphtha. And to our belief, there is no other plant in the world where this problem has been attempted to be solved by a coating of Teflon. And there were lots of discussions, and we have finally done the coating on these. Can you go to the next slide, please? Yeah, so there is a crude column overhead pipe for naphtha. This is coated with Teflon PFA. The next slide, please. 42-inch dia crude. Again, this is a complicated piece which were coated with Teflon. And next slide, please. Is another an elbow, a 42-inch diameter pipe. So these are all meeting unique challenges, and we thank Reliance for initiating this kind of innovative idea, and see where we go with that. And we would like to work with other industries also to do the same thing. We solve their corrosion problems, reduce the hazards, increase the safety, increase the life of this equipment, and most importantly, increase the uptime. So increase the time between two shutdowns. And this is how we would like to work with the industry. This has not been done for many years, mainly because this is a very conservative industry where the risks are normally very high, the political risk, the investment risk, etc. But now I think is a time to really go ahead and solve the problems of corrosion. There are plenty of them, and we are ready to work with the industry in the spirit of collaboration and solve them. Can you please go to the next slide? Mr. Nagar? Yeah. So this is another example of using the Teflon coating for protecting the internals of the diesel settler tank for the vacuum diesel plant. There are these acidic conditions and this life of the life of the tanks was limited. So this has been coated with Teflon from inside and do that. Can you go to the next slide, please? Another thing that we talk about in innovation is pushing the envelope, whether it's a temperature or a size or anything. We know that Teflon coating requires two basic things. One is the very good surface preparation, which is a very clean blasted surface without rusting. And second is the oven to bake the equipment. So when you do a very large piece of equipment, when you start blasting it from one side of the equipment, by the time you reach the other side, it would already start rusting. So we had to figure out a way of not allowing the surface to be rusted and keep it virgin, clean, white surface. And that we were able to do. And size of the size of the equipment is only a mental block in our mind about whether we can have an oven that size or not. Once we decide that we can do any size, then we can build an oven around it. Next slide, please. So these are the two pieces of equipment which have been coated. Mr. Nagar, can you go to this? Yeah, this is the second one. So we did a total of 5 pieces, starting from 100 tons to 200 tons. And so size is really not a limitation anymore. And so this is pushing the envelope. Can you go to the next slide? Again, generally everybody does coating in their own plant, especially Teflon coating, because it requires ovens and which are very closely controlled in terms of temperature, etc. The window of low baked to over bake is very small. But when our customer said that you come and do it in our plant, because we can't bring the equipment to your plant because of the logistics problem, so we agreed. And so we designed the oven for them, which they built. We provided the process, the technology, the manpower, the equipment, and we went and did this job in their plant. Probably this is the first time in the world that this has been done at site. And so, as I said, we are asking for working and collaboration with the industry to push the envelope of technology so we can solve problems. All problems are solvable provided we are willing to work on them. Next. These are the conventional downstream products application. This is on a spiral conveyor of a PBR plant, which vibrates and pushes the product up from ground level to the second floor. Next, please. This is again a coating on distributor plate for an HF tower. Next, please. These are the products which, of course, you guys have seen. The nuts and bolts, the fasteners, which are coated with PTFE, and they are used all the way from production wells up to the refinery and the petrochemical plants. Next, please. Next, please. Next, please. So this is one of the earlier equipment that we had quoted for Gale Pata. It's more than 20 years ago. It's still working. It's going strong. And at that time, we didn't have an oven this large. So we constructed an oven around it. This is about a trailer length. The other ones were about 2 trailer lengths or 3 trailer lengths, the one which we have done recently. And so this is for a, if you can see the ring in the bottom, that is a part of a bearing. It's about 7 meters in diameter. And the challenge was that since it's a part of the bearing, that we don't want any distortion of the ring. We want the distortion less than 0.1 millimeter over the 7 meter diameter. And that also we were able to achieve with proper controls and things like that. Teflon coated, not coated, but Teflon tube heat exchangers are being used in the oil-based power plant of Poland, and they scrub down the SNOx gases as well as recover heat from the flue gases. The same thing is going to be available from us, but in terms of metal tubes. Again, we thank Mr. Yuan and of Reliance Industry for inviting Chemours and Ami Polymers for collaboration on finding solutions to either to unsolved corrosion problems. I wanted to make it short, and I believe we haven't taken too much time. Thank you. If there are any questions, we could answer.
Hello. I would now like to invite Mr. Dabral to sum up, and I'm posting the questions in the chat. Hello. Mr. Dabral? There are questions.
Yes.
Yeah. So I just want you to sum up today's discussion, and then we can take it further. There are questions being put forward to the speakers. So I would,
Yes. Yeah. So thank you so much, my co-panelists, for the discussion. It was really helpful. Some of the technologies that you discussed were really wonderful and were different from what we see in the day-to-day affairs. Let's see what questions do we have for each and every one of us. I understand there were some issues with the sharing and with the platform for the first time, because we are fairly new to, I understand, this kind of exhibition. But yeah, we're getting used to it. So, Mr. Nagar, if you could post the questions.
Yeah. There was a questions for Mr. Albert. Mr. Albert, the question is there, but I think he has left. Hello. There is a question on PU as important class of coating, and how important is in today's context? Hello. 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 There's a question on PU and how important is this in today's context?
Should I answer?
Yes.
Yes. As far as polyurethanes are concerned, they are one of the key importance as far as your external structures integrity is concerned. They are having a very good resistance to the UV light, which retains their gloss as well as color. So PU coatings are one of the integral parts as far as any structure is concerned. It's a top coat basically. There is another type of polyurethane, which is aromatic one, that is having a very wide resistance to corrosion. It is normally applied at a very high thicknesses in the range of 1,000, 2,000, 3,000 kind of thickness, microns thickness. And these are mostly used as an underground pipeline linings, external linings. Okay, so that is the one thing. Another thing is, whenever you go for choosing the polyurethane, you should choose polyurethane material with its chemical understanding. This material available in both, that is aliphatic and aromatic materials. So if you have a requirement for the external gloss retention, color retention, go with aliphatic one. And if you have a corrosion resistance requirement and various chemical resistance requirement, you have to go with aromatic polyurethanes. One can easily distinguish, means a layman can easily distinguish by looking at the technical data sheet that the coating which is suggested to be applied at 30 to 60 micron is aliphatic, mostly aliphatic, and the coating which is to be applied above 500 microns, mostly aromatic, or to be applied as a primer above 50 to 75 microns can also be a aromatic one.
Okay. Thank you. There are questions addressed to Mr. Merrick. There's also a question addressed to on the green coatings application for the power industry, which is addressed to Mr. Sachin Joshi. And what we are doing is people are putting up the questions in the chat box. So you can directly go on the platform and you can reply there. And there are questions people are emailing it to us. So we will be compiling and sending it to you, emailing it to you, because we have overshot the time today. It's already 6 o'clock. So we will be writing to you. We have asked people to keep on posing the question. There's a question for Mr. Dabral also, but he will be presenting tomorrow in details about graphene technology and about coating for tank linings. So we will be putting up the questions in the chat for you to answer directly at the platform, and also emailing it to you. Now, I would like to thank all the panelists today for the wonderful session. Thank you all for your time for today's discussion. I would like to now hand over to Mr. R.P. Pandey, sir. Mr. Dabral, any closing note from your end for today's session before I hand over to Mr. Batra and Mr. Pandey to close today's session?
Yeah, I would really like to thank all of my co-panelists, and also at the same time, I see the way technology has changed. I guess a few of us have been attending this online exhibition for the first time in their, let us say, 50 years or 40 years of career, and it takes. It's also, I would believe, a small step in innovation that we show that, yeah, we are able to adjust to the new circumstances, and COVID cannot stop us from innovating. Yeah, no matter how old, how young, what time we have, what problems we have, we would go out, we would collaborate, and we would innovate. So thank you so much, all of you. Thank you.
Now, closing note from Batra sir and Pandey sir before we close the session, and we will be starting again.
Thank you, Masiji. In between, I could not be present because of some important meeting with the chair. Our CMD was holding meeting, so I could not. Okay, thank you.
Batra sir, for any closing note from your end? Sir, you are on mute, sir.
Yeah. Can you hear me?
Yes, yes.
Yes.
Yeah. The conference has come up to my expectation, because I wanted, I mentioned that there is an inflection point on the technology. And as Mr. Ravi Dabral said, that there were a lot of pleasant surprises about the technology. And I think the presentations were excellent. And I sat through all of them. And I'm so happy that you made it so interesting. Thank you so much, all of you, for making the conference to be successful. Yeah.
Do join us tomorrow at 2:30. We are starting the session 3 and session 4. We have wonderful lineup also in tomorrow, where we have people from NTPC, from GAIL, from ONGC IoT, Mr. Dinesh Kumar, from Chugoku Paints. We have from Detect Technologies. We have from Grand Polycoats, and we have Mr. Ravi Dabral also presenting tomorrow. So looking forward to a very interesting session. We had a lot of interactions chat happening in. So do keep joining in the platform also, because we will be having the concluding day for the exploration, for the power, and also for the refining and surface engineering and corrosion control also tomorrow. So thanks again, once again, for your wonderful time and energy and wonderful presentation. Thank you, sir.
Thank you.
Bye.
Thank you, sir.
Thank you.